Hello dear students, I am Praveen, your chemistry educator. Students, in this video, what we are going to do, we are going to cover the full redox reaction chapter. We will be covering each and every concept within the chapter along with questions. You know what? From the redox reaction chapter, every year in the NEET examination, we get at least 2 questions. And that you will be able to do after going through this video. Let me tell you one thing. In redox reaction chapter, you deal with a certain number of rules like while calculating oxidation number, the topic in which previously you used to follow at least 6 or 7 rules. So instead of 6 and 7 rules, now you can do the same topic just by 1 or 2 rules. After completing this session, what is your task? Your task is to practice. And we are providing the DPPs in the description, and also you can get those DPPs on the PW app. So download the app, and just like lakhs of students, you also start preparing your NEET examination, your NEET journey. So now students, let's first see that in today's video of redox reaction, what will be the topics that we will be covering, right? So first of all, we will be talking about oxidation number. Right? And here you can notice one thing, that we are discussing oxidation number even before the introduction of chapter or introduction of some of the terms we have in this chapter. Why? Because this oxidation number, students, it is a backbone of this chapter. You know what is backbone, right? This is the single concept which will be used in this chapter again and again. How we can calculate oxidation number. So after that, the rest of the topics will become very easy for you. So first we will focus on oxidation number, then we will see terms in this chapter like what is reduction, what is oxidation, what is oxidizing agent, what is reducing agent. Certain types of redox reactions we have, right? So what are those reactions? Then the most important topic, that is balancing of redox reaction. And here in the balancing part, we will look into both the methods of balancing, right? We will discuss how the redox reaction can be balanced using ion electron method, and also we will talk about the oxidation number method. And finally, after balancing, we will discuss regarding redox titration. But let me tell you one thing. In the redox titration part, right, if you have knowledge of law of gram equivalent, law of equivalent, right? So if you know law of equivalent, then this topic, redox titration, will be very easy for you, right? And for that, you can go and you can watch the mole concept topic or the one shot of mole concept. Inside that, you will find law of equivalent and all the details of it. So here, let's start with the very first topic, that is oxidation number. And let's first understand what is the meaning of oxidation number. Because you know what? For any topic, the very first thing is understanding the exact meaning of that term. Like for us here, oxidation number is a term, and we have to understand what is the meaning of oxidation number. Students, please listen carefully. Whenever you take a molecule or compound, right? So a molecule or compound, it can have multiple number of atoms, right? So in any molecular compound, whatever number of atoms is there, right? So out of that, take any particular atom and you hypothetically isolate that atom. When you hypothetically isolate any atom from the molecule, compound or ion, so whatever charge a particular atom will be getting, so that total charge is known as oxidation number. So overall you can say like that, take a molecule or compound, remove any particular atom from that, hypothetically of course, and when you remove that atom, so that atom, whatever total charge it is getting, so that total charge is called as oxidation number. So let's write down in short its definition. Like what will be the definition of oxidation number? So it can be defined as the total charge on an atom, the total charge on an atom when it is hypothetically isolated from compound, molecule or ion. And see, Because here hypothetically we are isolating the atom, so definitely even the oxidation number, it is a hypothetical term, right? Now, if you want to understand this definition, like what is the meaning of total charge here, what is the meaning of hypothetical isolation here, if you want to understand that, that can be done by simply taking one example. One example is enough. And let me take a very simple example for all of you. Students, you all know water, right? If you take one water molecule, so the formula of water molecule is H2O, right? And from the knowledge of chemical bonding, I hope you all know that how we can draw the dot structure of H2O molecule, right? The dot structure of H2O molecule will be like this. You have oxygen as your central atom, hydrogen as your surrounding atom, and oxygen is attached with both hydrogen atom with single covalent bond. So there is a single covalent bond between oxygen and this hydrogen atom, and there is a single covalent bond between this oxygen and this hydrogen atom, right? Of course, there will be lone pairs, but while calculating oxidation number, we don't have to talk about lone pairs and all, right? We have to only talk about the bond pair part. So in H2O, you can clearly see that oxygen is attached with hydrogen by single covalent bond. Now, suppose if I want to get the oxidation number of this oxygen atom, I want oxidation number of this oxygen atom. So for that, what I need to do? I need to isolate, or remove hypothetically this oxygen atom. Now, in order to remove oxygen atom from here, from this H2O molecule, what you need to do? You need to break the bonds. Whatever bonds are there which oxygen is creating here in this molecule, so those bonds you need to break, right? So here, if I break this bond, this single covalent bond, and if I break this single covalent bond, then my task will be done. By breaking these two bonds, my oxygen can be isolated. But the point is, when you break these bonds, suppose if I break this single covalent bond, so in it I have total 2 electron, right? And in this total 2 electron, 1 electron is of oxygen and 1 electron is of hydrogen, correct? Now, when you break this bond, what will happen? This bond pair will shift on more electronegative atom. And I hope from your periodic table, you know very well that oxygen is much more electronegative as compared to hydrogen. So in this case, because oxygen is more electronegative, when you break this bond, the electron pair will move on to oxygen atom. And when this electron pair will move on to oxygen atom, right? So this hydrogen, it is losing one of its electron. And that's why this hydrogen will get a +1 charge and oxygen will get a -1 charge. Now, overall, you can summarize this point like, if you break a single covalent bond, then more electronegative atom will get -1 charge and less electronegative atom will get +1 charge. In the same way, right, apart from single bond, you may have double bond, triple bonds in your structure. So in that case also, you have to do the similar thing. Suppose if a double bond is present between atom A and atom B, and I am calculating oxidation number, right? So for the calculation of oxidation number, suppose I need to break this bond. So when you break double bond, and suppose here that A is more electronegative. So if A is more electronegative and you are breaking this double bond, so in that case, A will get -2 charge and B will get +2 charge. Similarly, suppose that in any structure, you have triple bond. Right? So when you break triple bond for a calculation of oxidation number, so in that case, the charge distribution will be +3 and -3. Again, minus charge will be on the more electronegative atom. Like suppose in this case, out of P and Q, P is more electronegative. If P is more electronegative and I am breaking its triple bond, so then P will get what? -3 charge, Q will get +3 charge, right? So when you break single bond, charge distribution is +1 -1. When you break double bond, charge distribution will be +2 -2. When you break triple bond, charge distribution will be +3 -3. And always Negative charge is placed on more electronegative atom and positive charge is placed on less electronegative atom. Right? Now again, coming back to this H2O case, here I am breaking single bond, oxygen is more electronegative, so I gave -1 charge to oxygen, +1 charge to hydrogen. Also, for oxygen, I need to break this bond also in order to completely isolate this oxygen atom. So when you break this single bond, in that case what will happen? Again the oxygen will get -1 charge, hydrogen will get +1 charge because again oxygen is more electronegative. So after dissociating these two bonds, you can say that your oxygen will be isolated. But due to this dissociation, what will happen? Oxygen atom will get a total charge of -2. -1 we are getting due to fission of this bond and -1 we are getting due to fission of this bond. So -1 net charge will be what? -2. Now students, this is the value of oxidation number. Now you can say that in H2O molecule, the oxidation number of oxygen atom is -2. Not only that, apart from oxygen, here I can say that this hydrogen atom, right, it is getting a +1 charge total. If I isolate hydrogen, so I just need to break this bond. So when I break this bond, I isolate hydrogen, I will be getting +1 charge. So in the same H2O molecule, you can say that the oxidation number of hydrogen atom will be what? +1. So now I hope that you all have understood what is the definition, what is the meaning of oxidation number, right? What is the meaning of total charge here? What is the meaning of hypothetically isolated atom, right? So like this, you can calculate oxidation number for rest of the molecules, rest of the compounds. Now the next point is, we understood what is oxidation number, that it is total charge, right, on any atom in a molecule or compound or ion. But the next point is, students, when you try to calculate oxidation number, so it can be calculated by two different methods. You can calculate oxidation number by the dot structure, directly from the dot structure, and you can also calculate oxidation number from certain set of rules. We have certain set of rules. If you remember that, if you memorize that, from that you can find out oxidation number. But out of those two, out of the dot structure method and rule method, we always prefer, or the preferable method is dot structure method. And let me tell you, when I explained oxidation number previously, right, so there I have already used the dot structure method. Dot structure method is nothing like for any compound, for any atom, you have to get oxidation number. Just draw the dot structure, right? Isolate the atom by breaking the bonds. Assign charges +1, +2, -1, -2, +3, -3, right? And then find the total charge. That will be your oxidation number, right? So in dot structure method, one thing is for sure, you all need to have knowledge of drawing dot structure. But I hope that like when you talk about chemical bonding chapter, right? So in chemical bonding, you already had practiced dot structure a lot, right? Because see, I told you that oxidation number is backbone of redox reaction chapter, right? So just like this, dot structure is backbone of your chemical bonding chapter. So you should have knowledge of dot structure. You should have knowledge of drawing the dot structure. You should be very fluent in that, right? Now, if you know how to draw the dot structure, you can easily find oxidation number from that. Let's take a few more examples, students. Let's take a methane molecule, right? You know methane, very famous molecule, CH4. Suppose that in case of methane, I have to calculate the oxidation number of this carbon atom. Although we can find oxidation number of central atom, surrounding atom both, but most of the time you will notice that you are asked to find oxidation number for the central atom. So in case of methane, if I try to get oxidation number of the carbon atom, again from the dot structure, so how it can be done? First, you need to draw the dot structure of methane. It will be carbon, 4 hydrogen atoms in the surrounding, and each hydrogen will create a single covalent bond with your carbon atom, right? Now, in order to get oxidation number of carbon, I need to hypothetically isolate that. And how it can be done? By breaking all the bonds of carbon, right? So here, if I break if I break this bond, single covalent bond, so out of hydrogen carbon, carbon is more electronegative. So carbon will be getting -1 charge, hydrogen +1 charge. If I break this single covalent bond, again carbon more electronegative, so -1 charge, hydrogen +1. If I break this bond, again carbon is more electronegative, so it will get -1, hydrogen will get +1 charge. Lastly, if I break this bond, again carbon is more electronegative than hydrogen, so carbon will get -1 charge, hydrogen will get +1 charge. So after breaking these 4 single covalent bonds, I can say that carbon atom can be isolated from this, right? But when you break all those 4 bonds, what will happen? The carbon atom will get -1, -1, -1, -1, a total of -4 charge. Right? So in this case, you can say that your carbon atom has oxidation number of -4. And in the same molecule, if I ask what will be the oxidation number of hydrogen atom? So all the hydrogen, if you notice, right, after fission of their bonds, they are getting +1 charge. So in the same case, oxidation number of hydrogen will be +1. So now I think you all have understood, right, easily that how we can get oxidation number from the dot structure. The only thing is you should have knowledge of drawing the dot structure. If you know that, you are done. You will be easily calculating the oxidation number. So now, without wasting any time, let's take some of the most important examples of oxidation number or calculation of oxidation number that can be done by dot structure. Students, we have a molecule here whose formula is Br3O8. Br3O8. It is called as a tribromo octaoxide. Now, for Br3O8, the structure is 3 bromines are attached with one another by single bond, and the terminal bromine atoms, they have 3 oxygen with double covalent bond, and the central bromine, it has 2 oxygen atom with double covalent bond. Now here, suppose that if I have to get oxidation number of each and every bromine atom. So for simplicity, for convenience, let's do a numbering here, a random numbering, right? Let's say that this is my first bromine atom, this is my second bromine atom, and this is my third bromine atom. So now students, if I have to calculate oxidation number of the first bromine atom, how it can be done? By isolating it, by isolation. Now to isolate this bromine, what you need to do? You need to break this double bond. Again, oxygen is more electronegative, so for double bond, oxygen will get -2, bromine will get +2. You need to break this double bond. Again, oxygen is more electronegative, so -2, bromine will get +2. Again, double bond, again oxygen. Oxygen will get -2, bromine will get what? +2 charge. Correct? And lastly, if you break this bond, please focus here, students. Please focus here. When you break this single covalent bond, now this bond is present between same atom. Here also bromine, here also bromine. So when you break a bond between same atom, in order to get oxidation number, the charge distribution will be 0, 0. Because both the atoms have similar electronegativity. So if bond is there and it is present between same atom, so while calculating oxidation number, you need to put 0, 0 charge after due to dissociation of this bond. So after breaking all these double and single bonds, I can say that my first bromine will be isolated. Now what will be the total charge for the first bromine in this case? +2, +2, +2, 0. So +2, +2, +2, 0, the total charge will be +6. So I can say now that for the first bromine here, oxidation number is +6. In the same way, students, you can find oxidation number of the second bromine. For second bromine, if you break this bond, this bromine will get 0 charge. If you break this bond again between same atom, so both will get 0 charge. If you break this double bond, O is more electronegative, so -2 +2. If you break this double bond, O is more electronegative, so -2 +2. So in this case, 0 from here, 0 from here, +2 by breaking this, +2 but by breaking this. So total charge for the central bromine, second bromine, will become +2 +2, that means +4. So here, for second bromine, I can say oxidation number is +4. Now if you notice one thing, in the same compound, for the same type of atom, we are getting different oxidation states, oxidation numbers. So it is 100% possible that in a molecule, same atoms can have different types of oxidation number. Like here, for the first bromine, we are getting +6, and for second bromine, we are getting +4. Now, I have a task for you, all of you. Can all of you find the oxidation number of third bromine and tell the answer in the comment box? All of you, please do that and comment the answer in the comment box. For first, I am getting +6. For second, I am getting +4. And for third, it's your task. Right? Now, if I talk about this structure, this particular anion, it is nothing but S4O6 2-. Right? Now, if you look at the structure of S4O6 2- carefully, we have total 4 sulfur atoms here, right? And in that total 4 sulfur atom, the terminal sulfur atom, let me call it first sulfur, second sulfur, third sulfur, fourth sulfur, just for a reference. Now, for the first sulfur atom, if you notice, it is attached by double bond with oxygen, double bond with oxygen, single bond with oxygen, and single bond with sulfur. Now, if I want oxidation number of this sulfur, again, what I need to do? I need to isolate it. I need to break all the bonds hypothetically. So, for this sulfur atom, if I break this bond, which is between same atom, sulfur-sulfur, so charge distribution will be 0, 0. If I break this single bond, O is more electronegative, so O will get -1 charge, S will get +1 charge. If I break this double bond, O will get -2, S will get +2. If I break this double bond, again O will get -2, S will get +2. So in this case, if you notice, for the first sulfur atom, after breaking all the bonds, the total charge I will get is +2 +2 +1 0. So +2 +2 +1 0 is +5. So here, for the first sulfur atom, my oxidation number is +5. Now, for the second sulfur, if you calculate, it has only 2 bonds. One is this single covalent, one is this single covalent. And both the bonds are between same atom. Here also sulfur-sulfur, here also sulfur-sulfur. So if I break this bond, the charge distribution will be 0, 0. If I break this bond, again the charge distribution will be 0, 0. Right? So in this case, if you notice, after breaking these 2 bonds, the second sulfur, it is getting a 0 charge, total 0 charge. So here, oxidation number of this sulfur will be 0. So even that is possible. Oxidation number can be positive, can be 0, can be negative. Right? Now, again, I have a task for you. Can you calculate oxidation number of the third and fourth sulfur, and can you write down in the comment box? Right? And believe me, I will check your answers. I will check your answers in the comment box. Don't worry. Right? So, give the answers of third and fourth sulfur in the comment box, and I have a help for you. It will be similar to the first and second one. It will be similar to the first and second one. But now I hope that you have understood very well that how we can get oxidation number from the dot structure. Let's take few more examples. Like we have a molecule here whose formula is CrO5, chromium pentaoxide. It's a very famous molecule. If you notice its dot structure, it looks like butterfly. Butterfly, you must have seen butterfly, right? So because it looks like butterfly, we call it butterfly structure. But here we don't have to talk about that butterfly and all. We have to calculate what? Oxidation number. So suppose in this case, if I have to calculate, if my target is getting the oxidation number of the central chromium atom. So to get oxidation number of chromium atom, what I can do? I can break all the bonds which chromium is creating here. So when I break this single bond, O is more electronegative. So for single bond, -1 +1. This single bond, O is more electronegative, -1 +1. This double bond, O is more electronegative, -2 +2. This single bond again, O -1, Cr +1. Single bond again, so O -1, Cr +1. So after breaking these double bonds and single bonds, I can isolate chromium. But again, the chromium will get a total charge of how much? +1 +1 +1 +1 +2. So total charge is +6. So in CrO5, I can say that my chromium atom has oxidation number of +6. Right? So in CrO5, for Cr, the oxidation number is +6. Now, this is a very famous molecule, right? C3O2. Its formula is C3O2, and It is called as carbon suboxide. Sometimes when they will ask question, they will not give you the formula. They will simply write the name. They can ask like this: what is the oxidation number of carbon atom in carbon suboxide? So you need to understand that carbon suboxide is C3O2. Now in this C3O2, I have total 3 carbons, if you notice. And let me do some numbering here for reference. This is first carbon, this is second carbon, this is third carbon. Here if I calculate oxidation number of first carbon, I need to break this double bond. So O is more electronegative, it will get -2, carbon will get +2. I need to break this double bond also. It is between same atom, so charges will be 0, 0. So by breaking these two bonds, this carbon can be isolated. And then the carbon will get total charge of 0 + 2 + 2. So for the first carbon, oxidation number is +2. Now for the second carbon, if you notice, when you break this bond, it will get 0 charge. And when you break this bond, again it is a carbon-carbon bond. So again this carbon will get a 0 charge. So for the second carbon, after breaking these two double bonds, the total charge will be 0. For the second carbon, for the central carbon, I can say oxidation number is 0. And similarly, students, for the third carbon, if you notice, when you break this bond, it is getting 0 charge. When you break this bond, O will get -2, C will get +2. So for third carbon also, total oxidation number will be +2. So in this case also, you can notice that we have 3 carbon atoms. But for 3 carbon atoms, the oxidation states are different. For 2 of them, the oxidation number is +2, and for 1 carbon, the oxidation number is 0. And these examples which I have took, right, which I took, CrO5, C3O2, Br3O8, S4O6 2-, these examples are very important for you. Sometimes in exam, they directly ask these structures or oxidation numbers from these structures. So now, after understanding oxidation number from the dot structure method very well, now let's talk about the second part, the second way of calculating oxidation number by rule. Students, let me tell you, if you look into the books, right? So in this part, you will notice almost 6 or 7 rules are given. So you need to learn 6 or 7 rules in order to calculate oxidation number by rule method. But let me tell you one thing, it's not necessary. Only one rule or one point is enough. Only one rule or one point is enough. There is a point. If you remember that point, so from that you can calculate oxidation number easily. So let me write that point first. That single point which will give you the oxidation number. The point is very simple. The point is very simple. Sum of oxidation number of all the atoms in a molecule or compound is 0. Means what? You take any molecule, any compound, whatever atoms are in it, right? If you add oxidation number of each and every atom, so the summation of oxidation number will be always 0. But it will be 0 only for molecule or compound. If it is an ion, so in case of ion, the summation of oxidation number will be equal to the net charge of ion. So let me add that point also. Sum of oxidation number of all the atoms in a molecule or compound is 0, and for ions it is equal to net charge of ion, net charge of ion. Correct? Now again, let's understand this point by example. Let's take some molecule, some compound, some ion, and let's try to understand this point from some examples. Students, let's say I have taken HNO3. Okay, when I write HNO3, you need to understand that it's a molecule, not ion. Molecules and ions are very easy to identify. If certain group of atoms are written, if certain formula is written and no charge is there, so no charge means 0 charge, right? So it is a molecule. And when certain atom or group of atoms is there, and in the formula part, they have mentioned some charge, -1, -2, -3, +1, +2, +3. So when charge is given overall, so that is your ion. So this is the way you can identify that whether it is a molecule, whether it is ion, right? So HNO3 is a molecule. Now in HNO3, if you notice, we have one hydrogen atom, one nitrogen atom, and total 3 oxygen atoms. So according to that point which I wrote, I can say oxidation number of hydrogen atom plus oxidation number of nitrogen atom, and because there are total 3 oxygen atoms, so 3 into oxidation number of oxygen atom should be 0. Summation of oxidation number of all the atoms should be 0 in case of molecule, right? Suppose if I take another example, if I take H2SO4, sulfuric acid. So in sulfuric acid, if you notice, we have total 2 hydrogen atom, 1 sulfur atom, and 4 oxygen atom. So here if I apply that point, I can say that because we have 2 hydrogen atoms, so 2 into oxidation number of hydrogen plus 1 sulfur atom, so oxidation number of sulfur atom plus total 4 oxygen atom, so 4 into oxidation number of oxygen should be 0. So when it is a molecule or compound, in that case, summation of oxidation number of all the atoms will be 0. Now, let's take some of the ions also. Suppose students, I have this PO4 3-. As soon as I write this formula, you need to understand it is an ion because it has a charge of total -3. Now in this ion, if you notice, we have total 1 phosphorus atom and 4 oxygen atom, right? 4 oxygen atoms. So here, if I apply my point, I can say that for 1 phosphorus, oxidation number of phosphorus atom plus we have 4 oxygen. So 4 into oxidation number of oxygen atom should be equals to not 0, net charge, which is -3. -3. Let's take another example. Let's take NO2 minus, very famous ion, nitrite. In case of nitrite, if I apply that point, I have 1 nitrogen atom, so oxidation number of nitrogen plus we have 2 oxygen atom here, so 2 into oxidation number of oxygen should be equals to the net charge is -1, so -1. So now I think you all have understood this point, that summation of oxidation number of atoms in molecule compound it is 0, and in case of ions it is equals to net charge, right? And just by this point you can find oxidation number, because you know what type of questions you get in your exam. They will give a compound, they will give a molecule like this, and within this molecule they will ask oxidation number of any of the atom, and most of the time they will ask for the central atom. Like suppose in case of HNO3, I have to get oxidation number of nitrogen. In case of H2SO4, I have to calculate oxidation number of sulfur. In case of phosphate, phosphorus. In case of nitrite, nitrogen. So you will have to calculate oxidation number of any of the atom within that molecule. Now, please listen carefully. The atom whose oxidation number you have to calculate, keep it unknown. Put it some X, Y, Z, right? But for the rest of the atoms like hydrogen, oxygen here, again hydrogen, oxygen here, oxygen here, oxygen here. For the rest of the atoms, you have to assign oxidation number by your own, right? So the one whose oxidation number we have to find out, that will be unknown for us, and for the rest of the atoms, we will assign from our side the oxidation number values. So here we have a point. For some of the atoms elements, you have to memorize, you have to remember the oxidation number. But it is not a tough task to do. It's a very easy task to do. See, in your periodic table, you must have memorized elements group wise, because that's the most necessary thing you can do. And you need that for the whole inorganic chemistry. You need to memorize elements group wise. Atomic number wise is not useful. If you are memorizing the periodic table atomic number wise, hydrogen, helium, lithium, don't do that. Memorize periodic table group wise, especially for the S block and P block. Now that point will help you even in this case, because whenever you see that you have an element of group 1. Group 1 means lithium, sodium, potassium, rubidium, cesium, francium, right? So whenever you see that there is an element of group 1 and you have to assign, please again focus on this statement. When you have to assign, you don't have to calculate, when you have to assign oxidation number of element of group 1, so you can assign as +1. It's very simple, group 1 +1, group 2 +2. Whenever you are assigning oxidation number of any element of group 2, beryllium, magnesium, calcium, strontium, barium and radium. So for any element of group 2, you can assign what? +2. And now after group 1, group 2, directly you go into group 17. Directly you move into group 17. If you have to assign oxidation number of any of the element of group 17, fluorine, chlorine, bromine and iodine. Again I am repeating one point. I am telling these points or these oxidation numbers when you have to assign. Suppose when you have to calculate oxidation number of chlorine, fluorine, bromine, iodine, it can differ. It can have different values. But when for some unknown species you are calculating the oxidation number and there you have to substitute by your own oxidation number of any of these fluorine, chlorine, bromine, iodine, you can assign what? -1. Right? Last but not the least, when you assign for oxygen, you will assign -2. Of course, when you assign for oxygen by your side, so you will be assigning what? -2. But when you calculate oxidation number of oxygen, sometimes you can get -1, +1 because it has variable oxidation state. But whenever you are assigning from your side for the oxygen atom, you will be assigning what? -2. So group 1, group 2, group 17, apart from these three groups, just remember oxygen and one more element, hydrogen. Okay, for hydrogen, you can assign two oxidation numbers, +1 and -1, depending upon it is attached with metal or non-metal, and that you can see from the formula from the dot structure itself. If the hydrogen atom is attached with non-metal, if it is attached with non-metal, so in that case, you assign oxidation state of hydrogen as +1. And if your if your hydrogen is attached with, of course, metal, if your hydrogen is attached with metal, in that case, you assign for -1 for hydrogen. Right? So this much you need to remember. I think that these three are easier, right? Because you know group wise elements. So group 1, group 2, group 17, +1, +2, -1. It's very easy. Apart from this, only two. Oxygen -2, hydrogen +1 with non-metal and -1 with metal. So total you can say that we have only 2 points. Only 2 points is there, students, in the calculation of oxidation number. One point is summation of oxidation number of all the atoms in a molecule compound is 0. For ions it is net charge. And second point is, for some of the elements we have to remember the oxidation number. For group 1, group 2, group 17, oxygen and hydrogen. Now from this knowledge, we can calculate oxidation number. Let me give you an example. Let me tell you one example how from the rule you can find, and I hope that you all have noted down these points. I hope that you all have noted down these 2 points for the rule method of calculation of oxidation number. Now let me tell you the same thing with an example. Suppose if I take KMnO4, okay, why I am taking KMnO4, do you know? Because KMnO4 you will find in this chapter many times, potassium permanganate. So now let's say that for KMnO4, I have to calculate oxidation number of Mn, right? By rule, not by dot structure. So how I will do this? First of all, this is a compound, right? So summation of oxidation numbers will be 0. 1 potassium, so oxidation number of potassium, plus 1 Mn, so oxidation number of Mn, plus 4 oxygen, so 4 into oxidation number of oxygen, it should be 0, correct? Now, for Mn we have to calculate. So for the rest of the atoms, we will assign oxidation number from our side. Now, Because this potassium is from group 1 and just now I told you that for potassium group 1 you will assign +1 oxidation number. So here I will put +1 plus oxidation number of Mn, keep it as it is or you can put it X here, plus 4 into, for oxygen again we have to assign, and I told you that for oxygen you will assign what? -2. So for oxygen oxidation number is -2, it is 0. Now if you calculate this, +1 and this is 4 into 2, -2 -8. So +1 -8 is -7. So it will be oxidation number of Mn -7 equals to 0. Finally, oxidation number of Mn will come out +7, right? So when you are learning this first time, you can do like this. But when you have practiced a lot, then you can do this in your mind also. These calculations can be done in your brain, right? But this is the way. By rule, you can calculate your oxidation number. Let's take another example. Let's practice more because practice makes you perfect, right? Let's take another example. If I take oxalate ion, C2O4 2-, and suppose in case of oxalate ion, I have to calculate oxidation number of this carbon atom. Again, first point is summation of oxidation number of all the atoms will be equal to net charge here because it is ion, not molecule. So 2 carbon atom, so 2 into oxidation number of carbon atom plus 4 oxygen atom, so 4 into oxidation number of oxygen atom should be equals to what? Net charge is -2, so -2. Now in this case, for carbon I have to calculate. So for oxygen, I will assign from my side, and again for oxygen, what will be the assigned value? -2. So here you can write that 2 into oxidation number of carbon plus 4 into oxidation number of oxygen, you can put -2 is equals to -2. So finally, 2 into oxidation number of carbon, 4 into -2 is -8 equals to -2. -8 if you take into RHS, it will be +8. -2 plus 8 is +6. You need to be very good in your calculation always. So 2 into oxidation number is +6. And finally, oxidation number of carbon, if you calculate, so +6 upon 2, it will come out +3. So now I think, just like dot structure, you all have understood how you can get oxidation number of atoms in case of molecule, compound, or even in case of ions, right? And always remember that oxidation number is your backbone. Before starting anything in this chapter, you need to be very good in your oxidation number calculation. So students, from the same oxidation number, let's do some of the questions. Take your pen, paper and brain, PPB, remember? Use your PPB and try to solve this before me. Pause this video and try to solve, give the answer. Later on, you can match your answer with me. So the question is, consider the following compounds: KO2, potassium superoxide, H2O2, hydrogen peroxide, H2SO4. What will be the oxidation number of the underlined elements? So in KO2, you have to find for K. In case of H2O2, you have to find for oxygen. In case of H2SO4, you have to find for sulfur. It's a very easy question. See, first if you take KO2, right? In KO2, we don't even have to find. We have to tell oxidation number of potassium. Students, potassium is the element of group 1, right? Potassium is the element of group 1. And you know that group 1, they don't have variable oxidation state. They have a fixed oxidation state of +1. So no need to calculate. We already got that. Potassium has a +1 state in it, right? Now, for the second one, H2O2, if you see, in this case, you have to find for oxygen. Now, for oxygen, you can't say -2 directly because oxygen can have +1, -1 states, 0 states also. So here you need to calculate. In case of H2O2, let's write this according to rule because this is a molecule. So 2 hydrogen atoms, so 2 into oxidation number of hydrogen plus 2 oxygen atom, so 2 into oxidation number of oxygen, it should be 0 because it's a molecule. Now, for oxygen you have to find. So for hydrogen you will assign, and hydrogen is attached with non-metal in this. Oxygen is a non-metal. So whenever hydrogen is attached with a non-metal, you assign +1 for hydrogen, right? So here 2 into, for hydrogen I can write +1, plus 2 into oxidation number of oxygen should be what? 0. So finally 2 into oxidation number of oxygen will be -2, because in RHS it will be minus, and oxidation number of one oxygen atom will come out -1. So in KO2 it is +1, in H2O2 for oxygen it is -1, and for H2SO4 if you calculate, for sulfur atom again 2 into oxidation number of hydrogen, because we have 2 hydrogen, plus oxidation number of sulfur, plus 4 into oxidation number of oxygen should be 0. Now, in this case, for sulfur we have to find, for hydrogen and oxygen we will assign from our side. So, 2 into, for hydrogen you will assign +1, because only non-metals are there. So, it is self-understood that here hydrogen is attached with oxygen atom, that is non-metal, plus oxidation number of sulfur, plus 4 into, for oxygen you assign -2, equals to 0. So +2 and 4 into -2 is -8. So +2 minus 8 is -6. And if you take that in RHS, it will become +6. So for oxidation number of sulfur atom is +6 here. So +1, -1, +6. The answer will be +1, -1, +6. Of course, it should be C. It should be C. Let's check it out. Of course, it will be C. Yeah, C. Right? And the surprising part is, this question came in the NEET 2025 examination. So now you can understand from oxidation number how easy questions you will be getting, just for the calculation part. Let's not stop here. Let's do another question. Can you do this? The oxidation state not shown by Mn in the given reaction. So here they have given a reaction. MnO4 2 minus plus 4H plus gives 2 MnO4 minus plus MnO2 plus 2H2O. Now here we have total 3 species in which Mn is present. Now in all those 3 species, you have to find oxidation state of Mn, and then you have to answer that which oxidation state is not present here. +6, +2, +4, +7 and +3. So one by one, if you calculate, in case of the first one, MnO4 2 minus, MnO4 2 minus, again same rule, oxidation number of Mn atom plus 4 into oxidation number of oxygen atom should be -2. For Mn we have to calculate. So for oxygen I will substitute from my side, that will be -2. So 4 into -2 is, okay, here it is -2, not 2, of course. So 4 into -2 is -8, and if you take that into RHS, so -2 plus 8 will become +6. So in this case, the manganese has oxidation state of +6. So +6 is there, A is there. Now for the second one, MnO4 minus, if you do MnO4 minus, in this case again we have 1 Mn and 4 oxygen atoms. So oxidation number of Mn plus 4 into oxidation number of oxygen, it is ion, so net charge will be -1. Again for Mn you have to calculate, so oxidation number of Mn plus for oxygen you will put from your side, so 4 into -2 equals to -1. In this case 4 into -2 is -8, and if you take that into RHS, so -1 plus 8 will become +7. So here the Mn has oxidation state of +7, so +7 is also present, D is also there. Now the last one, MnO2. Okay, MnO2 is not ion, it's a compound, right? So here oxidation number of Mn plus 2 into oxidation number of oxygen, it should be 0. Now again for Mn you have to find, so oxidation number of Mn plus 2 into, for oxygen you assign from your side -2, it should be 0. So 2 into -2 is -4, into RHS if you take, that will become +4. So oxidation number of Mn in MnO2 will be how much? +4. So +4 is also present. So in these 3 compounds, the oxidation states are +6, +7, +4. But they have asked that which oxidation state is not shown by Mn. So not shown means what? +2 is not there and +3 is not there. Means B and E is not present. B and E is not present. B and E. So in this case, your answer should be D. Of course it is D. B and E is not there. And again, this question was from NEET 2024 examination. So you saw two questions, one from 2025, one from 2024. But in both the questions, you just had to calculate the oxidation number. Believe me, every year you get a question from oxidation number. It's fixed. When you will give your NEET examination, in that also, you will get one question directly from the calculation of oxidation number. So now students, after understanding oxidation number, let's see that in our chapter redox reaction, what are the few terms that we use again and again, right? First thing is, what is oxidation and reduction? Students, if you notice, even the name of chapter, redox reaction, right? Redox is made up of RED and OX. This RED means reduction. This OX means what? Oxidation. So even the name of chapter is kept on the basis of reduction and oxidation. So now first, let's try to understand what is the exact meaning of these two terms, oxidation and reduction. And also, there are two aspects, there are two concepts. One is classical, the older one, and then we will look into the modern concept. Both we will see. So first, if I talk about oxidation and reduction, in terms of a classical concept, the older concept. So previously, or old concept is, whenever there is addition of oxygen atom in any species. So if there is a molecule, atom or ion, and in that oxygen atoms are getting added. So if oxygen atoms are getting added, then that process is called as oxidation. Similarly, one more point is there. If you find that from any compound, any ion, we are having removal of hydrogen atom, right? So whenever hydrogen atom is getting removed, so even that process we term as oxidation. One more point you can add here is that if there is addition of electronegative elements like oxygen, fluorine, halogen and all, right? So whenever electronegative element is getting added in any species, so that process is also called oxidation. Now similarly, the exact opposite of oxidation, we call it reduction. So addition of oxygen atom is oxidation. So you can say that removal of oxygen atom is nothing but reduction. Removal of hydrogen atom is oxidation. So that means opposite of that, addition of hydrogen atom in any molecule, compound, ion is known as reduction. Addition of electronegative element is oxidation. So opposite of that, addition of electropositive element will be termed as what? Reduction. So these are the old concepts, right? Like if you take some certain example, suppose if you take this C plus O2 converts to CO2. In this simple reaction, you can see that when C plus O2 is reacting to give CO2, right, carbon atom, it is having addition of oxygen atom in order to convert into CO2. So here in the carbon, because oxygen is getting added, addition of oxygen, so we can say that carbon atom is going through oxidation. Similarly, suppose if I consider this reaction, N2 plus H2 gives NH3, Haber's process, right? Very famous. So in this reaction, if you notice, N2 plus H2 gives NH3, the nitrogen, it is having addition of hydrogen in order to form ammonia. So here, because nitrogen is having addition of hydrogen, so addition of hydrogen is what? Reduction. I can say that in this second process, nitrogen atoms are getting reduced. Nitrogen atoms is having reduction, right? And if you talk about this, suppose Mg plus O2 gives MgO. Here if you notice, again, magnesium is having addition of oxygen. Okay, oxygen is also highly electronegative element, one of the most electronegative element. So you can say like this, that when Mg plus O2 is reacting, converting to MgO, here Mg is attaching electronegative element. So whenever attachment of electronegative element happens, so that process is oxidation. So this is nothing but oxidation of Mg, right? Similarly, if I consider this reaction, suppose Na plus Cl2 gives NaCl. In this process, you see that chlorine is one of the most electronegative element again, and it is getting added into sodium. So whenever addition of electronegative element happens, so that process is nothing but oxidation. So these are some of the classical concepts of oxidation reduction we have, right? But classical concepts are still followed, especially in your organic chemistry. If you notice, in your organic chemistry, you still follow these concepts. But for this particular chapter, right, the modern concept is more important. The modern approach of oxidation reduction is more important. So let's focus more on the modern concept of oxidation reduction, right? And in the modern concept of oxidation reduction, it is defined, students, according to electron transfer. It is defined according to electron transfer. See, there can be two possibilities. Either some species can accept electron, or some species can give electron, donate electron, right? And on that basis, we define oxidation reduction. The point is, whenever there is loss of electron from any atom, molecule or ion. So any atom, molecule or ion, if it is losing electron, so that particular process will be known as oxidation. But opposite of that, if there is a process in which certain atom, molecule or ion, it is having gain of electron, electrons are getting added into it. So that process will be called as what? Reduction. Let's take some example to understand this according to electron. Suppose, students, if I take sodium, it can be easily ionized into Na plus by loss of one electron. So in this particular process, if you notice, the sodium atom, right, when it is converting into Na plus ion, it is losing one electron. So because sodium is losing one electron, I can say that sodium is having oxidation here. Sodium is having oxidation here. On the other hand, suppose if I take oxygen atom takes one electron to convert into O minus 1 ion, right? Now in this process, if you notice, this particular oxygen atom is accepting an electron. It is having gain of electron. So here I can say that when this oxygen atom is converting into O minus, so this process is nothing but reduction, right? So whenever someone is losing electron, that's oxidation. Whenever someone is gaining electron, that's reduction. Okay, some people even use tricks for that. Some people even use trick to memorize what is oxidation reduction. Please don't do that. If you require trick to remember this thing, believe me, don't study. Just leave study, right? Because this is very easy, right? Gain of electron is reduction, loss of electron is oxidation. Few people even make trick for this, like oil rig. Oxidation is loss of electron, reduction is gain of electron. Please don't use tricks in the easy concepts, right? Keep your tricks for the tough points, right? Which are difficult to memorize. In the easy concepts, do not use trick. Remember them directly. So from now onwards, always remember loss of electron, oxidation, gain of electron, reduction. And one more point. Oxidation is one process, reduction is one process. Suppose if they are happening simultaneously, if there is any process in which both oxidation and reductions, they are happening. So when both oxidation reduction, they happen simultaneously, then that process is called as redox reaction. Then that process is called as redox reaction. Right? I hope you all will remember that. What is the meaning of redox reaction? Correct? Now, the immediate next point is, we understood that loss of electron is oxidation, gain of electron is reduction. But how to check it? If any chemical equation is given, how we will identify that whether oxidation is happening or not, reduction is happening or not, or which one is getting oxidized or which species is getting reduced? So that's the main point now after understanding oxidation reduction, right? How you can identify that whether oxidation or reduction is happening or not. Students, I told you that oxidation number is the backbone of the chapter. Why? Because when you try to figure it out that whether oxidation is happening or not, reduction is happening or not, so that can be checked again with help of oxidation number only. So point is this. Now let's see that how this oxidation number will help you to find oxidation reduction. Let's take an example. Just take an example, a very famous one. See, if you take zinc, it reacts with copper sulfate to give zinc sulfate and copper. Now, if you try to calculate oxidation number of each species, especially the central atom, here zinc atom, it's a pure element. Students, please remember that for pure elements like pure non-metal or pure metal, oxidation number will be always 0. Why? If you want to know the logic behind it, go into the basics of oxidation number calculation, especially the dot structure method. See, if I take pure zinc metal, so inside that on micro level, I will be having only zinc atoms. So whatever bonding is there, that is between same type of atom. And I told you that when bond is there between same type of atom, and if you break that, the charge distribution is 0, 0. So any pure element you take, whether it is a pure metal or non-metals like phosphorus, graphite, diamond, right, sulfur, fluorine, chlorine, bromine, iodine, for any pure substance, pure element, the oxidation number is always 0, because in the structure of that substance, same atoms are linked with each other. So whenever you isolate atom, the charge distributions are 0. So always remember that. Here zinc will have 0 charge. Similarly, here we have pure copper, right? So again for pure copper, oxidation number will be what? 0. Now for copper sulfate, if you assign oxidation number, so for O4 it is -8, for sulfur +6. Overall for sulfate you can directly write -2, because you know sulfate is iron, right? Sulfate, carbonate, bicarbonate, nitrate, nitrite. You all remember that from your 9th class. I hope so. So sulfate, it's an ion. Directly we can assign the charge of sulfate as -2. So if charge of sulfate is -2, the net charge of compound should be 0. So copper will have a charge of +2. Here again sulfate has charge of -2. So zinc will have charge of what? +2. So once you are done with the oxidation number, just focus that whether your oxidation number is changing or not. If oxidation number is changing, that means something is happening there, oxidation and reduction. More precisely, if you notice that your oxidation number has increased, so that means it is your oxidation process. And if you notice that your oxidation number has decreased, that means it is your reduction process. It's very easy. Assign the oxidation number. If oxidation number is increasing, oxidation. If oxidation number is decreasing, reduction. Like in this case, in this example, if you notice, zinc is going from 0 state to +2 state, right? So here I can say that zinc is having what? Oxidation, as its oxidation number increases. If you talk about copper sulfate, so in copper sulfate, copper is +2 and here copper is 0. So for copper, it is going from +2 to 0. So we are having decrease in oxidation number. So I can say that when copper sulfate converts to copper, it is nothing but reduction, because for copper, oxidation number decreases. And I think in this case, in this particular case, one example is enough to understand. Because you have already understood, right, how to find oxidation number. If not, go practice that again. And once you are able to find the oxidation numbers of each species, each atom, then you have to just see that whether your oxidation number is increasing or decreasing. Increase means oxidation and decrease means what? Reduction. Let's take some more example. Let's take few more examples to understand, to check how we can find oxidation and reduction. Suppose if I take this FeCl2, it is reacting with potassium permanganate, KMnO4, and it is converting into FeCl3 along with Mn2 plus ion. So in this case, if you have to find out which one is having oxidation, which one is having reduction, how you can do? Again, assign the oxidation states first. In FeCl2, For chlorine, you assign -1. So for 2 chlorine, you assign -2. So for net 0, Fe should have a charge of +2. In KMnO4, for K you assign +1, for O -2, so for 4 oxygen -8, for Mn it should be +7, then only the sum of oxidation number of all the atoms will become 0. In FeCl3, for chlorine you assign -1, so for 3 chlorine -3, for Fe it will be +3. And here it is already given the charge of Mn is +2, so that will be the oxidation number of Mn. Now if you focus carefully, you can see that oxidation number here, it is changing for Fe, going from +2 to +3, a kind of increment. So if your oxidation number is increasing for FeCl2, that means this is your oxidation process. We are having oxidation of what? FeCl2. And for KMnO4, especially for Mn, if you notice, it is going from +7 to +2. So +7 to +2 means what? We are having a decrement in oxidation number. So here I can say that my KMnO4 is having reduction when it is converting into what? Mn2+. So in this particular example, FeCl2 is going through oxidation and KMnO4 is going through reduction. So now I think with help of oxidation number, you can find out that which one is getting oxidized and which one is getting reduced. Right? And now you have understood very well what is the meaning of oxidation and what is the meaning of reduction. Now, after oxidation reduction, we have another term. It is again very important. Sometimes in your exam, they directly ask question. They will give you equation. They will ask that which one is oxidizing agent, which one is reducing agent. So, oxidizing and reducing agents also, you need to understand very carefully. See, first of all, oxidizing agent, in short, we write it OA. Reducing agent, in short, we write Ra. Try to understand this first on the basis of electron itself. Students, please notice, oxidizing agent in your reaction is that compound, that ion, which accepts electron. Which accepts electron. While reducing agent is that compound which donates electron. Which donates electron. One more thing, even the oxidizing reducing agent you can find out on the basis of again oxidation number. Because when your oxidizing agent, when it will accept electron, so because electron themselves they have -1 charge. Electrons have -1 charge in it, right? Correct? So whenever oxidizing agent is there, because it accepts electron, its oxidation number, its total charge will decrease due to addition of electron. Right? So for oxidizing agent, if you want to check that species whose oxidation number is decreasing. And for reducing agent, the species whose oxidation number is increasing. That will be your reducing agent. Right? So oxidizing agent will accept electron and in the reaction, its oxidation number will decrease. And reducing agent will donate electron and in the reaction, its oxidation number will increase. So now students, after the term oxidation reduction, let's talk about another very important term, that is oxidizing agent and reducing agents. Now, from the topic oxidizing agent and reducing agent, you get questions directly in your examination many times. Like there will be questions, some equation will be given and they will be asking that which of the following reactant is oxidizing agent or which of the following reactant is reducing agent. Right? So first of all, let's understand what is the exact meaning of oxidizing and reducing agent. Students, oxidizing agent, in short, if I write like OA, OA means oxidizing agent, and reducing agent, in short, if I write RA, RA stands for reducing agent. Try to understand this first in terms of electron transfer, because in terms of electron transfer only, we have also understood what is oxidation and reduction. So point is this, students, please listen carefully. During the redox reaction, the reactant which will accept electron, which will gain electron, that reactant is nothing but your oxidizing agent. So I can write it like this, oxidizing agent is that reactant which will accept electron during the course of reaction. Right? Also, if you talk about reducing agent, so definitely the concept of reducing agent will be exactly opposite of oxidizing agent. If your oxidizing agent is accepting electron, that means reducing agent will be that reactant which will lose electron, right? Which will lose electron or which will donate electron, right? And this is how you can explain that the one who is donating electron, that is your reducing agent, and the one which is accepting electron, that is your oxidizing agent. But again, just like oxidation reduction, if you want to check that which one is your oxidizing agent and which one is your reducing agent, again students, in order to check that, you need to use the concept of oxidation number. So previously we saw that with help of oxidation number, we can judge whether oxidation is happening or reduction is happening. Now, with help of oxidation number only, we can also check that which reactant is oxidizing agent and which reactant is reducing agent. How? Simply, whenever any species will accept electron, now try to understand this. Electrons, they have negative charge. One electron has -1 charge, right? So when electron will be added into something, right, its charge, its total charge will decrease because of addition of electron. So oxidizing agent can be identified by the logic that they will have decrement in the oxidation number. So in your reaction, if you see that for certain reactant, its oxidation number is decreasing. So the one for which oxidation number is decreasing, that is your oxidizing agent. And similarly, in terms of reducing agent, if you see, so for them, the oxidation number should increase. So again, with help of oxidation number, right, assign first in the equation the oxidation number of all the atoms, right, and in the reactant side, always check for reducing agent and oxidizing agent in the reactant side because they have nothing to do with product, right? So in the reactant side, the one whose oxidation number is increasing, right, that is your nothing but reducing agent, and the one whose oxidation number is decreasing, that is nothing but your oxidizing agent. Now let's try to get this with an example, with a very simple example. Suppose if I consider this reaction, I hope you all know this from your childhood, right? Hydrogen can react with, can combine with chlorine to produce HCl gas. Now, in this reaction, if you want to find out that out of H2Cl2, because these two are the reactants here, out of H2Cl2, which one is your oxidizing agent and which one is your reducing agent? First, assign the oxidation number. So once again, if you notice, H2, it is pure element, right? Pure hydrogen gas. I told you that for pure elements, oxidation number of each atom will be 0. So because H2 is pure substance, here oxidation number of hydrogen will be 0. And again Cl2 is a pure substance. So in Cl2 also, the oxidation number of chlorine atoms will be 0. But in case of HCl, right, the hydrogen, it is attached with chlorine, which is a non-metal. So hydrogen will have oxidation number of +1, and that's why chlorine will have oxidation number of -1, right? You know that +1 -1 net charge of molecule should be 0. Now here, if you observe what is the change in oxidation number for H2Cl2, you can clearly see that in H2, for per atom, oxidation number is 0, while in HCl, for hydrogen, the oxidation number is +1. So I can say that for H2, my oxidation number is increasing. That means what, students? The one whose oxidation number increases, that reactant is called as what? Reducing agent. So in this reaction, I can say that H2 is my reducing agent. Let me write it here. In this reaction, H2 is my reducing agent. And similarly, if you observe for chlorine, so in the reactant, chlorine has oxidation number of 0, but in the product, chlorine has oxidation number of -1. So for chlorine, the oxidation number is going from 0 to -1. That means it is decreasing. And whenever there is a decrease in oxidation number for certain species, so that species we call it as oxidizing agent. So in this particular reaction, our chlorine is oxidizing agent. So I think if you know oxidation number, if you know how to assign oxidation number very easily by looking at whether your oxidation number increasing, decreasing, you can figure it out that which reactant is oxidizing agent and which reactant is reducing agent. And once again, I am reminding you, you will be getting questions from this directly in your examination. whether it is about checking oxidation, reduction, or oxidizing agent or reducing agent. Correct? Now, after understanding all those four terms, oxidizing, reducing agents, oxidation, reduction, let us see a very important point. Although you will not find this topic in your books, but I have created it so that it will help you later on in the balancing part, right? And the point is how we can count number of electron transferred during oxidation reduction, of course. Previously we have seen, right, that whenever oxidation happens, so there is a loss of electron, and whenever reduction happens, there is a gain of electron. Now the point is, for any particle, if oxidation is happening, that means it is losing certain number of electrons. So exactly how many number of electrons are getting lost or gained during oxidation reduction, that counting we have to do. But the most interesting point is, just like oxidation reduction, just like oxidizing reducing agent, even the calculation of number of electron transfer is done by oxidation number itself. So now I hope you have understood why I said that oxidation number is backbone in this chapter. Right? Here, what you need to do for oxidation number, right, in the reactant side and product side, if it is changing. So whatever change in oxidation number is there, those many number of electrons will be transferred. So here you can directly say that number of electron transferred during oxidation reduction process is equals to number of electrons transferred during oxidation reduction is equals to change in oxidation number, And again, let's try to understand this with one example, right? At least one example. Suppose if I consider this reaction, all of you, I have a sulfite ion SO3 2-, and that sulfite ion is reacting with KMnO4, potassium permanganate. It is a very famous redox reaction, students, sulfite with KMnO4. Here, sulfite will convert into sulfate ion. And if it is acidic medium, later on you are going to see that what is the meaning of acidic medium and basic medium. If it is acidic medium, then your KMnO4 will change into Mn2+. Now here we are going to calculate how many number of electrons are getting transferred, but apart from that, let's practice the previous points also. Right? Let's practice first that which one is getting oxidation, which one is having reduction. Then let's check which one is oxidizing agent, which one is reducing agent. And then let's check how many number of electrons are getting lost or gained during oxidation reduction. Correct? One by one. So, first of all, to do any of these things, first thing is you need to assign the oxidation number of each atom. In case of sulfite ion, if you notice, the net charge is -2. For the 3 oxygen atoms, if you assign, you will assign -2 for each oxygen. So for 3 oxygen, it will be -6. And here, the net charge should be -2. So for sulfur, I will assign +4. So that sulfur's +4 and O3 -6, if you add it, you will be getting net -2. Now, KMnO4 is a compound. So for K, if I assign +1, for the 4 oxygen atoms, if I assign -8, then for Mn, it will be what? +7. So in KMnO4, the oxidation numbers of potassium, Mn and O4 is +1, +7 and -8. Similarly, if you talk about sulfate ion, here it is ion, so net charge is -2. Now, for the 4 oxygen atoms, the net charge will be -8 because 1 oxygen -2. So for total 4 oxygen, -2 into 4, -8. And what I assign for sulfur, so that net charge becomes -2, so it should be +6, right? So +6 -8, if you add it, you will be getting overall -2 charge. And for the last one, Mn, the charge is already mentioned +2, so that will be the oxidation state, right? In the product side, Mn has oxidation number of +2. Now, as we have assigned oxidation number of each species, just check it out, whose oxidation number is increasing and whose oxidation number is decreasing. Here, if you notice, for sulfur, in the reactant side, we have +4. In the product side, we have +6. So for the sulfur in the sulfite, oxidation number is increasing. So I can say that SO3 2 minus here, it is getting oxidized, right? And because its oxidation number is increasing, I can also say that sulfite is your reducing agent. I hope you have noted down that point. The species whose oxidation number increases, that is your reducing agent. And similarly, if you check KMnO4, in KMnO4 for the Mn atom, here charge is +7, in the product side charge is +2. So it is going from +7 to +2, its oxidation number is decreasing here. So for KMnO4 we are having reduction, and the one which is going through reduction will be your oxidizing agent. So one thing you can notice here, that the relation is kind of opposite. The relation here is kind of opposite. Like oxidizing agent will have reduction and reducing agent will have oxidation, right? Now, our interest is calculating number of electron transferred, and I told you it will be equals to change in oxidation number. So here, if I separately write the sulfite ion, right? In sulfite ion, it is changing to sulfate ion, and I have already written the oxidation numbers. For this sulfur, oxidation number is what? +4, and for this sulfur, oxidation number is +6. So it is changing from +4 to +6. So overall change in oxidation number here, if you find delta of oxidation number, it will be 6 minus 4, it is 2. So if change in oxidation number is 2, that means here we are having loss of 2 electron. Why loss of 2 electron? Because this is the process of oxidation. So in oxidation, when you have loss of electron, so that will be written in the product side. So I can write it here, we are having loss of 2 electron. In the same way, you can do it for reduction process. So again, if you want to check for KMnO4 here, so KMnO4 is having reduction again, and in case of reduction, we will be having gain in number of electrons. So here in KMnO4, the Mn has oxidation number of +7, and in the product side, Mn has oxidation number of what? +2. Now in this case, if you calculate change in oxidation number, so it is going from 7 to 2, so change will be 7 minus 2, that means 5. So in this case, I will have transfer of total 5 electron. Transfer of total 5 electron, because change in oxidation number is 5. And as it is reduction, so you know that in case of reduction, electron is added, electron is gained. So in this case, 5 electron will be added in the reactant side. So one more thing you have understood here, that in the oxidation process, whatever number of electron is getting lost, so that we write in the product side, and in the reduction process, whatever number of electron is added, so that we write in the reactant side, right? So now I hope and you have understood very well each of these things: oxidation, reduction, oxidizing agent, reducing agent, and how from the change in oxidation number we do calculate how many number of electrons are getting transferred during oxidation reduction. Right? So after understanding all these points, let's practice some of the questions from the same topic. Let's see what type of questions you will be getting in your examination. Right? So again, use your PPB, pen, paper, brain, and try to solve this question before me. Yeah, I will be much more happier, right, if you solve all these questions before me. So pause this video, solve it. Later on, you can match the answer. Now here the question is, which reaction is not a redox reaction? So we have to just check that which one is redox and which is not redox, right? Now how to do this? A very simple question. A reaction will be redox reaction only if some of the species is having reduction and some of the species is having oxidation. And you know very well how to check oxidation reduction from oxidation number. So one by one, in the reactant product side, just assign oxidation number and then you can answer which one is redox, which one is not redox. Like in the first example, if you notice, we took it earlier, right? Zn plus CuSO4. This is pure metal, pure zinc. So oxidation number 0. For the sulfate, we can write charge overall directly -2. So for copper, it is +2. In ZnSO4, for the sulfate ion, charge -2 again, and for zinc, it is +2. And for copper, because it is pure copper, pure metal, oxidation number is 0. Now if you observe carefully here, Zinc is changing from 0 to +2. Oxidation number increases, oxidation. Copper sulfate, copper changing from +2 to 0, reduction. So because in the first case, we are having oxidation and reduction, so overall it is a redox reaction. But they are asking which is not a redox reaction. Similarly, now if you check for the second one, in KClO3, potassium chlorate, K will assigned +1, O3 will be assigned -6. So for chlorine here, the charge is, oxidation number is +5. And this is I2, pure iodine. So again for pure iodine, charge oxidation number will be 0. Now in KiO3, if you notice, potassium will be +1, O3 will be -6. So in this case, the iodine atom will have oxidation number of +5. And again we have a pure chlorine here, so its oxidation number will be 0. In this case also, if you notice, chlorine is going from +5 to 0. Its oxidation number is decreasing. So this thing is having reduction. And iodine is changing from 0 to +5. So its oxidation number, the oxidation number of iodine is increasing. So iodine is having oxidation here. So someone is getting reduced, someone is getting oxidized. So overall this is again redox reaction. So this is not our answer. Now if you check the third one, just now I took this example. So I hope you remember it, right? Here H2's oxidation number 0, chlorine's oxidation number 0. In the HCl, hydrogen has +1 oxidation number, chlorine -1. So in this case, hydrogen is oxidized, chlorine is reduced. So even this reaction is your redox reaction. Now ultimately, because A, B, C is not the answer, so our answer will be D. But let's check how. In the last equation, if you notice, barium, group 2 element, its oxidation number is +2. And for 2 chlorine here, -2. In Na2SO4, sulfate -2, and for Na2 charge is +2. In the product side again, barium sulfate, so sulfate has a charge of -2 and barium has a charge of +2. And in NaCl, chlorine -1, Na +1. Now here students, if you observe carefully, you will notice that none of the atoms having change in oxidation number. All the atoms in the reactant and product, they have the same oxidation state, right? In the reactant, barium has +2 state. In the product also, barium has +2 state. In the reactant, chlorine has for 1 chlorine -1. In the product also for 1 chlorine -1. In reactant, sodium for 1 sodium +1 charge. In product also for 1 sodium +1 charge. Sulfate, sulfate. So in the D option, none of the species is having increase or decrease in oxidation number. That means what? It is not having oxidation reduction. So this is not a redox reaction. So our answer here, it should be D. Answer will be definitely D. You can see that. And the fantastic part is, yes, the fantastic part is, this question came in NEET 2024, right? So it is a very recent question. But these types of question you do get in your examination, right? So let's not stop here. Let's do few more questions from these topics. Like what is the change in oxidation number of carbon in the following reaction? So a reaction is given. Again, I hope that you are doing it before me. So a reaction is given and you have to just answer that for the carbon atom, what is the change in oxidation number? So just calculate the oxidation number of carbon atom in the reactant side and product side. You can answer then. In the reactant side, carbon is present as methane. In methane, if you have to calculate for carbon, then for hydrogen you will assign from your side, and for hydrogen you will assign +1 per atom. So for 4 atom it will be +4. And because it's a molecule, so net charge should be 0. So here for carbon it will be -4. Done? So in the reactant I can say that carbon has oxidation state of -4. Now in the product side, if you check, carbon is there in CCl4, right? Again, for carbon to calculate, for chlorine I will assign from my side, and I told you that for chlorine you can assign -1. So for 4 chlorine it will be -4, and for carbon it will be +4. Then only the net sum will be 0. So now if you notice, for carbon it is changing from -4 to +4. -4 to +4. So definitely in this case, the answer will be B option, right? Answer will be B option. Definitely that's your answer. And again, this easy question came in NEET 2020 examination, right? This question, right? If you notice, the question is all about calculating oxidation number only, but they asked in terms of equation. Once you calculate oxidation number in the reactant side and once in the product side. But just by calculating oxidation number, you can solve these types of problem. So now I think I have given you proof. I gave you the proof that oxidation number is the main thing in this chapter. So focus on oxidation number as much as you can. Now, can you answer this? Hot concentrated sulfuric acid is a moderately strong oxidizing agent. I hope you already know that concentrated H2SO4 is a oxidizing agent. It can act as an oxidizing agent, right? Now the question is, in the given reactions, in the given equations, in which case it is not showing oxidizing behavior, or in which case your H2SO4 is not acting like a oxidizing agent. So out of 4, in 3 cases H2SO4 is behaving like oxidizing agent. Only in 1 case it is not behaving like an oxidizing agent. And again, you can check that by oxidation number. Like in the first equation, if you notice, in this H2SO4, if I break down the oxidation number, so for 2 hydrogen, charge is +2, for 8 oxygen, charge is -8, and for sulfur, the charge is +6. And in the product side, the H2SO4 is converting into what? SO2. So in SO2, for 2 oxygen, charge is -4, and for sulfur, charge is +4. So here if you notice, students, when H2SO4 converts to sulfur dioxide, SO2, the oxidation number of sulfur is changing from +6 to +4. So your oxidation number is decreasing here. And I have told you already that the reactant whose oxidation number decreases, that is your oxidizing agent. So in this case, I can say that H2SO4 behaves like an oxidizing agent. And you can generalize a point here. See, whenever your H2SO4 converts into SO2, so there H2SO4 is functioning as an oxidizing agent. Like here in the rest of the options, you can notice that in the option B, again H2SO4 converts to SO2. So here also it will be acting like an oxidizing agent, right? In the third option also you can notice that H2SO4 again converts to SO2. So in this case also, your H2SO4 is acting like an oxidizing agent. But in the last option, if you notice, here the H2SO4 is converting into sulfate only. So in H2SO4, sulfur has oxidation number of +6, and in the sulfate also, oxidation number of sulfur is +6. So there is no change, right? And this is not even a redox reaction. If you calculate oxidation number of each species, you will notice that in the option D, in the equation D, none of the atoms is having change in oxidation number, right? So here H2SO4 is not acting like oxidizing agent, and this is not even a redox reaction. So in this case, your answer will be definitely D. And again, this question came in NEET 2016 examination. So now you can notice, now you can observe, right, what type of problems you get in your NEET examination from the topics like oxidation, reduction, oxidizing agent, reducing agent, calculating number of electron, predicting whether it is a redox reaction or not. So now students, let's discuss like how these redox reactions, which we have understood now, I hope you have understood what is the meaning of redox reaction now, right? So these redox reactions, they have been classified, right, according to what is happening during the process, right? And those classifications you need to understand very well. Although let me tell you one thing, these types of redox reaction, it will look very much familiar to you, because these types of topics you must have seen in your class 10th also, right? But in 10th class, we don't call it types of redox reaction. In class 10th, we call it simply types of chemical reaction. But both are similar. They have similar meaning, also similar is there. So the very first redox reaction we have is combination reactions. I think it is a self-explanatory terms. Combination means what? Attachment of multiple particles. So if there is a redox reaction, and during that redox reaction, certain particles are forming bond between each other, certain molecules, ions are combining with each other, they are having addition. So that particular reaction will be called as combination reaction. For example, examples are very good in these cases to understand things quickly. For example, if you notice here, the first reaction. In this you can see that carbon is combining with oxygen to produce carbon dioxide. Very basic, very fundamental reaction we have. But of course, it is a redox reaction in which carbon is having oxidation, oxygen is having reduction. But if you notice, in this case, in the reactant side, the carbon we have and oxygen we have, these two are forming bond between each other to produce CO2. So we are having combination, we are having addition of carbon and oxygen atoms in this. Similarly, if you notice the second case, second example here, MgN2 reacting to give magnesium nitrite. Magnesium and nitrogen is combining to give magnesium nitrite. So here again, if you notice, in the reactant side you have pure magnesium, pure nitrogen, but they are creating bond in between them, more precisely ionic bond in between them to produce what? Magnesium nitrite. So whenever two or more particles, they create bond in between them to give some product. So that type of reaction is called combination reactions. And let me tell you one thing, from this you will be getting identification type of problem always in your exam. Like they will give you equation and they will ask that which one of the following is an example of combination reaction. Only that's the possibility from this topic. So after that, the next reaction, the next type of redox reaction we have, students, is decomposition reaction. Again, this term is also self-explanatory. See, decomposition means what? A kind of dissociation. Suppose that you have a particle. A particle means a molecule, ion, compound, right? And if that compound is dissociating into two or more compounds, right? So there you will have mostly fission of bonds, only dissociation of bonds. So in a compound, when bonds will break, it will produce two or more compound. And if it is a redox reaction, then we call it decomposition redox reaction. For example, if you notice, it's a very famous reaction we have. Potassium chlorate dissociates into, decomposes into KCl and O2. Here if you notice, in the reactant side, potassium has oxidation number of +1, O3 has -6, chlorine has +5. But in the product side, in KCl, potassium +1, chlorine -1, oxygen 0. So definitely it is a redox reaction where chlorine is having a reduction and oxygen is having oxidation. But apart from redox reaction, in this case, overall what is happening, this one KClO3 particle is decomposing to give you KCl and O2. So whenever particle dissociates, decomposes, and it is a redox reaction, then we call it decomposition redox reaction. So we understood combination, we understood decomposition. So now let's quickly go and let's see the next type of redox reaction, which is displacement. Even this is again self-explanatory. You understand, right? Displacements means what? When one particle replaces another particle from a compound, right? Like there is a compound AB. Suppose if I write a generalized reaction for displacement. So generalized means what? I have a compound AB. It is reacting with some element C. And during the course of reaction, suppose C is replacing B from the compound. So now the new compound will be what? AC, and B will go out. So when any atom replaces other atoms from a compound, so that type of reaction is called what? Displacement reaction. And of course, if it is redox, it is called displacement redox reaction. Now, for example, if you notice, when Cr2O3, chromium oxide, reacts with aluminium metal, it gives you what? Aluminium oxide plus chromium. Here if you notice carefully, overall in this reaction what is happening? The aluminium metal is replacing the chromium metal from the oxide, right? So we are getting oxide of aluminium and chromium is getting displaced here as a pure chromium, right? Now, if you notice, displacement reaction can be further classified, right, as metal-metal displacement, non-metal displacement. Like in this case, aluminium, which is a metal, it is displacing chromium, which is another metal. So here, one metal is displacing another metal. If you see the next example, here you can notice that pure iron reacting with water, it is giving what? Iron oxide with H2 gas. So here in this equation, if you notice, from H2O, iron is displacing the hydrogen atoms. right? And that's why we are getting oxide of iron, and hydrogen we are getting in the pure form. So again, this is a displacement where iron is displacing the hydrogen. But in this case, right, there is a difference. In the previous case, a metal was displacing another metal. But in this case, if you notice, a metal is displacing a non-metal. Iron is displacing the hydrogen, right? Similarly, if you see the third reaction, this is also displacement. H2O plus F2 gives HF plus O2. But in this one, if you notice, from this compound H2O, the fluorine is displacing the oxygen atom. And that's why we are getting hydrogen fluoride along with pure oxygen, right? And in this case, if you notice, fluorine, which is a non-metal, it is displacing oxygen, which is also a non-metal. So a metal can displace metal, a metal can displace non-metal, a non-metal can displace non-metal. So all these three types of displacement redox reaction we can have. Again, I am telling you, from this topic, you will get only one type of problem, that will be identification problem. Which one is combination, which one is decomposition, and now which one is displacement, right? But finally, one of the most important classification of redox reaction is disproportionation reaction. Students, disproportionation reaction. It's very important for you. Out of all those four, the most important one is disproportionation. See, in disproportionation, what happens? You take a compound, it will have oxidation reduction. But from the compound, same element will be oxidized and reduced. From the compound, same element will be oxidized and reduced. Then that reaction you can call as disproportionation reaction. Like here, if you see this example, if you figure out which one is getting oxidized, which one is getting reduced here. So when hydrogen peroxide is decomposing into H2 and oxygen. So if you see carefully the oxidation number, in the reactant side, for two oxygen atoms, charge will be -2. So for one oxygen atom, charge will be -1. This is -1 per atom. And in the product side, in H2O, per atom oxidation number is -2, and in pure oxygen, of course, it is 0. So here, if you notice, the oxygen from H2O2, it is getting reduced into H2O. It is getting reduced into H2O, and the same oxygen is getting oxidized in form of O2, right? So I can say that from this compound H2O2, the same element oxygen is having reduction also, oxidation also. So whenever this happens, that particular reaction is called as disproportionation redox reaction, right? So now I think you have understood easily all those four types of redox reaction, whether it is combination, whether it is decomposition, whether it is displacement, and whether it is disproportionation. Always remember disproportionation, right? Now, let's see a question from the topic, that is types of redox reaction. I told you will be getting identification kind of problem. So which of the following reaction is a decomposition? Decomposition. And please do not get confused between decomposition and disproportionation, because both looks quite similar, right? But in case of decomposition, different elements will be having oxidation reduction. In case of disproportionation, same element will go through oxidation reduction. So here, if you notice carefully, in the first reaction, the pure phosphorus has oxidation number of 0. And in the product side, if you notice, in pH3, phosphine, the oxidation number of phosphorus is -3. And in H2PO2 minus, for H2 plus 2, for O2 -4, net charge should be -1. So phosphorus should have a charge of +3, right? So here, if you notice, this P4 is converting into phosphine and H2PO2 minus. So in this case, from the P4, same element, phosphorus, is having oxidation as well as reduction. So if same element is having oxidation reduction, it is not decomposition, it is disproportionation. Likewise, if you compare, if you see the next case, lead nitrate, right? In lead nitrate, for the 2 nitrate ion, charge will be -2. For Pb, lead, charge will be +2. In the product side, if you notice, for PbO, -2, +2. For NO2, charge is -4, for nitrogen +4, and for pure oxygen 0. In this case, if you notice, in the reactant side, we have only one compound. But here, we are having oxidation of oxygen and reduction of nitrogen. So although oxidation reduction is happening for one compound only, but it is not happening for the same element, right? Oxidation here, it is happening for oxygen, and reduction is happening for what? Nitrogen. So from the same compound, if two different elements are getting oxidized, reduced, it is not disproportionation, it is decomposition. So here answer should be B. Answer should be B. Definitely. I hope you have understood the difference between decomposition and disproportionation, right? In both cases, same compound will go through oxidation reduction. But if from the compound different elements is having oxidation reduction, it is decomposition. If same element is having oxidation reduction, it is called disproportionation, right? And again, this question came in when NEET 2022 examination, right? So in NEET exam also you get these type of identification problem. Can you do one more, a similar type of question, all of you? Here the question is about a disproportionation reaction. Here the question is about disproportionation reaction. So some equations are given 1, 2, 3, 4, and you have to answer that out of these 4, which one is having disproportionation. Now again, that can be done with help of oxidation number, right? From the compound, same element, oxidation reduction means disproportionation. If you check one by one, in the first option, in the first equation, reactant side we have copper having +1 oxidation number. In the product side we have copper 2 plus, copper 0. So here for the copper only, oxidation number is increasing as well as oxidation number is decreasing. So oxidation reduction is happening for the same element. That means what? This is definitely a redox reaction. And of course, not only a redox reaction, this is definitely a disproportionation reaction, right? Now, if you check the second one, in MnO4 2 minus, net charge is -2. So for O4, charge will be -8. For Mn, charge will be +6. Here +1. In case of MnO4 minus, net charge -1. So for O4, -8, Mn +7. In case of MnO2, -4, +4. Now in this case, if you notice, students, you can see that the Mn, it is going from +6 state to +7 state, means oxidation. And it is also going from +6 to +4 state, means reduction. So again, MnO4 2 minus, from this compound, the same element Mn is having oxidation as well as reduction. Means this is also a disproportionation redox reaction. Now if you check the third one, in KMnO4, now I am directly writing, you can calculate. Mn has oxidation number of +7, here it has +6, here it has +4, right? And oxygen 0. So in this case, you can notice that Mn is getting reduced into +6. But again, in +4 also it is having reduction. So in this example, for Mn, only reduction is happening. Here oxidation is happening for oxygen atom. So definitely this is not a disproportionation redox reaction, right? So this is not our answer. And finally, if you check for MnO4 minus plus Mn2 plus gives MnO2. So here Mn has +7 state, in this +2, and in MnO2, Mn has +4 state. Now in this case, if you notice, +7 to +4 reduction, and +2 to +4 oxidation. But there is a point. In this case, these two Mns are not present in the same compound. So although same element is going through oxidation reduction here, but those elements are not present in the same compound. MnO4 minus is different, Mn2 plus is different. Instead of that, here you notice that when they are getting oxidized and reduced, they are forming a single compound. They are oxidizing and getting reduced to create a same compound. So it's not disproportionation. Instead of disproportionation, it has given some different name. Students, you can note it down. This reaction is called comproportionation reaction. Comproportionation reaction. And comproportionation looks exactly opposite of disproportionation. In disproportionation, from same compound, elements are oxidized, reduced to give you two different species. And in comproportionation, two different compounds oxidize, reduced to give you a single compound. Right? But here they are not asking about comproportionation, they are asking about disproportionation. So only 1 and 2 is your disproportionation reaction. So definitely in this case again the answer will be B. Answer should be B. Yes, it is B. And this identification problem again you got in the NEET 2019 examination. So now I think from the types of redox reaction topic you can solve the problems, because ultimately you have to just identify that whether it is disproportionation, comproportionation, combination, decomposition or displacement. And most of the time they will ask question from disproportionation, comproportionation and decomposition. These three are more important. So now students, let us discuss the most important topic in this chapter, and from this you get many questions in your exam. That is how to balance a redox reaction. Now, when you try to balance redox reaction, so we have two different methods here. One is called ion electron method or half reaction method, and the other one is oxidation number method. Just like oxidation number, right? In oxidation number also you saw that we had two methods. One was dot structure and one was using certain rules. So here also we have two methods, ion electron and oxidation number method. But out of those two, even if you know one method, so that will be enough for you, because in your NEET exam you get questions and you get options there, right? So no one is going to ask that which method you had used, right? So, but we will understand, we will discuss both the methods. But for you, I am telling that any one method, if you know, that is more than sufficient for you. So let's see one by one, and first discuss how to balance using ion electron method or half reaction method. Both are same, ion electron or half reaction method. See, in this case, if you go into your books and all, you will find that total 7 or 8 steps are given. And all those 7, 8 steps you have to memorize. You have to mug up them, right? So here what you can do, here you can create a short trick. Trick to memorize those steps easily in your brain. Now, how to do that? Just remember few words. Few words is enough for you. Only few words, right? Words like separate, then balance atoms, then balance electron, then add again, and then balance charge. So I have written a single line. In that line, few terms, few words are there, like separate, balance atom, balance electron, add again, balance charge. But let me tell you, this explain the whole step of balancing here, right? So let's understand why I wrote these terms, or what is the meaning of these terms here. See, when you try to balance any redox reaction by ion electron method, so there your first step will be, take the redox reaction, write down the oxidation number of each species, then check that which one is having oxidation, which one is having reduction, and after doing that you have to separate oxidation and reduction reactions. You have to write the oxidation part separately and you have to write the reduction part separately. So that point I have written in a single word, separate. Here separate means what? Separate the oxidation half and reduction half. Oxidation half and reduction half. Now see, if you remember this point that we have to separate oxidation half, reduction half, right? It is obvious that to separate oxidation half, you should know that which one is having oxidation reduction. And to find oxidation reduction, it is self understood that you should assign the oxidation number first. So all those points can be remembered, like the first step here is separate oxidation half and reduction half. Now, once you are done with separating your oxidation reduction half in the redox reaction, Now our next step, next task is balance atoms. So here eventually you are going to use heat and trial method. Here what you can do, you can balance all the atoms manually in the half equations, or you can skip oxygen hydrogen if you want, because oxygen hydrogen I personally balance at the end. So here, apart from oxygen hydrogen, except oxygen hydrogen, try to balance rest of the atoms manually by heat and trial. Right? Now, after balancing the atoms apart from oxygen hydrogen, your next step will be balance electron. Now the point is, balance electron. Which electron? You know that during oxidation reduction there is loss of gain of electron, and I have already told you how to count number of electron just for this balancing method, right? So after balancing atoms, now you calculate first that during oxidation reduction how many electrons are getting transferred, and if those electrons are not same in the oxidation half reduction half, balance those electrons here, and after balancing just simply add it again. Add it again means what? Initially you separated the oxidation reduction half, and finally here you are adding those oxidation reduction half, right? The main step is up to this only. Up to this, and up to this you don't require knowledge of medium, because in the ion electron method you will notice that mediums will be given, acidic medium, basic medium. So up to this point it is not medium dependent, it is common for any medium, acidic or basic. Up to this step you have to follow always. But when you go after adding into the final step, that is balance charge, so here what you need to do, you need to calculate the charge of reactant side, product side, and you need to balance those charges. And here during the charge balancing part we need knowledge of medium, because when it is acidic medium, now again you know that acidic means acid gives you what? H plus. So in case of acidic medium you will balance charge by H plus, and then you balance hydrogen by water. So in case of acidic medium, charge balancing will be done by adding H plus, and then hydrogen will be balanced by H2O. And if your medium is basic, so you know that base gives you what? Hydroxide ion, OH minus ion. So in case of basic medium, you do charge balancing by OH minus, and here you can balance the oxygen or hydrogen using H2O. Correct? So just remember these words now. Separate, balance atom, balance electron, add again, balance charge. From these words, you will remember all those steps. Now, whatever steps I have explained, right, because it is incomplete without example. Balancing is always incomplete without explaining it with example. So all these steps which I have mentioned, let us see with help of an example, students. Here I have a equation, I have a redox equation, redox reaction in which Fe2 plus is reacting with dichromate to give Fe3 plus and Cr3 plus. And of course, the medium of this reaction should be acidic. Although in questions it will be written, and why I know it, because this dichromate ion, this will always function in acidic medium, right? In all the redox reaction, if you see that in the reactant side dichromate ion is there, so the medium of that reaction will be always acidic for dichromate. For KMnO4 it can be different. For potassium permanganate it can be neutral, it can be strongly basic, weakly basic, acidic, all. But for K2Cr2O7 it will be acidic. Now our task is balancing it. Balance this equation. Now what I said the first step should be separate the oxidation reduction half. Now you think, I have to separate oxidation reduction. So first I need to get that. Now first I need to identify that which one is having oxidation and which one is having reduction. And that can be done by assigning what? Oxidation number. So first you assign oxidation number of each species. Like here for Fe it is already given 2 plus. In this case if you notice, for dichromate net charge is -2. For the 7 oxygen atoms charge will be -14. So for 2 chromium charge will be +12. Now please be clear in that Here this plus 12 charge is for 2 chromium atom. If you look at it for 1 chromium atom, the charge should be plus 6. So for 2 chromium, total charge plus 12, and for 1 chromium here, charge will be plus 6. Now in the product side, for this Fe, oxidation number is already given, 3 plus. And for this chromium also, oxidation number is already given, 3 plus. Now if you check, you can clearly see that here for Fe oxidation number is increasing. So Fe2 plus is getting oxidized, and for chromium it is going from plus 6 per atom to plus 3 per atom. So for chromium it is decreasing, the oxidation number is decreasing. So Cr2O7 2 minus is having reduction here. So now just separate those two and write it separately. I can write like this: oxidation half and reduction half. Oxidation half and reduction half. In case of oxidation half, I will write the oxidation part only. Means Fe2 plus converts to Fe3 plus. That's it. Right? And do not bother about in the overall equation whether it is H plus H2O is present or not, because those things will come later on during charge balancing. So here write only those things, those part which is having oxidation and reduction. In the reduction half, I can write it like dichromate ion Cr2O7 2 minus converts to Cr3 plus. Right? So I am done with my first step, separate. I have separated the oxidation half and reduction half. Now let's go into the second step. Second step was, apart from oxygen, hydrogen, try to balance all the rest of the atoms. So in the oxidation half, if you notice, I have one iron in the reactant and one iron in the product. So it is already balanced, leave it. In the reduction equation, if you see, here we have 2 chromium atom and here we have 1 chromium. So chromium is not balanced. Now using heat and trial, multiply with 2 here. If you multiply with 2 here, now in the product we have 2 chromium, in the reactant also we have 2 chromium. We have 7 oxygen here, in the product there is no oxygen, but do not bother about this. Oxygen will be balanced at the end during charge balancing, even hydrogen. Right? So now I am done with my second step. I have balanced all the atoms because some of them were already balanced, but I have balanced chromium. So I have balanced all the atoms other than hydrogen, oxygen, right? Now let's move quickly on to the third step. Third step was balance electron. Which electron? Which are getting transferred during oxidation and reduction. So before balancing electron, definitely you need to calculate it, that how many electrons are getting transferred during oxidation reduction, and that can be done by change in oxidation number. But please listen carefully. Many students make mistake here. When they calculate change in oxidation number, so they do that for one atom. Don't do it. Here, while calculating total number of electron transferred, you need to consider all the atoms. You need to consider the overall total oxidation number. Right? And then you have to find the change. Like here, we have one iron atom whose charge is plus 2. And we have one iron ion here whose charge is plus 3. So plus 2 to plus 3, right? The net change is 3 minus 2, that is 1, and it is oxidation. So I will write in the product side, we have loss of 1 electron here, because change in oxidation number is 3 minus 2, that is 1. In case of reduction, if you notice, for 1 chromium charge was plus 6, but for 2 chromium, the total charge was plus 12. So change will be calculated on total charge, not by one atom, right? That point I am telling you to remember. So for 2 chromium, the total charge is plus 12 here, and for 1 chromium it was plus 3, but now we have 2 chromium, right? So 2 into Cr3 plus, now the total charge will be how much? Plus 6. So for 2 chromium here in the product side, the net charge will be plus 6. So here it is changing from plus 12 to plus 6. So change is 12 minus 6, that means 6, and because it is reduction, so there will be gain of electron. So I will write in the reactant side plus 6 electron. So here I can see that in oxidation we are having loss of 1 electron, and in the reduction we are having gain of 6 electron. Now my task here is to balance those electrons, and that can be done by cross multiplying. Here 1, here 6. So multiply this whole equation by 6 and this equation by 1. So when you multiply with 6, it will become 6 Fe2 plus, 6 Fe3 plus, 6 electron. And here also we have 6 electron. As soon as you have balanced the number of electron, then the next step is add those equations again. Initially you separated them, now you add them again. Now you add them again, right? When you add it, the net equation will become 6 into Fe2 plus, so 6 Fe2 plus dichromate Cr2O7 2 minus gives 6 Fe3 plus again plus 2 Cr3 plus. The main part of balancing is this much only. After this, we have to just do charge balancing. But the main points are these are only. These are the main points. Separating, balancing atom, balancing electron, and add it again. I hope that you all have understood these points up to this. And in these points, I didn't mention about medium, if you notice. Because up to these steps, medium does not require. Right? Medium requires in the last step when we do charge balancing. Correct? So, after adding them, now let's talk about charge balancing step, the last step. Here students, charge balancing means balancing charge of reactant and product. So first you need to calculate here the total charges. In the reactant side, if you notice, 1 Fe has plus 2 charge here. So 6 Fe will have a total of plus 12 charge. 6 into 2 plus 12. There is one dichromate whose charge is minus 2. So this has a charge of plus 12, this has a charge of minus 2. If you add it, plus 12 and minus 2, the total charge of reactant side will become how much? Plus 10. Similarly, in the product side, 1 Fe has a charge of plus 3. 1 Fe has a charge of plus 3. So 6 into plus 3, it has a total charge of plus 18. And 1 chromium has a charge of plus 3. So 2 chromium will have a charge of 3 into 2 plus 6. So in the product side, if you see the total charge, so plus 18 and plus 6, the net charge will be how much? Plus 14. Now you compare. You will see that in the reactant side total charge is plus 10, in the product side total charge is plus 14. So definitely they are not same. Of course it's not 14, 18 plus 6 is 24. Let me correct it, right? Let me do the correction here. Yeah, plus 18 plus 6 is plus 24. Okay. So in the reactant side charge is plus 10, in the product side charge is plus 24. Definitely they are not same. Now these charges we have to balance. Either you have to make this plus 24 into plus 10, or you have to make this plus 10 into plus 24. So plus 10 can be converted to plus 24 by increasing the charge, and plus 24 can be converted to plus 10 by decreasing the charge. But here, because the medium is acidic, so in acidic medium, you can balance your charge only by H plus. Students, H plus means plus 1 charge, right? So whenever you add H plus, so that means you are increasing the charge by 1 unit. Now here if you carefully notice, charge is low in the reactant side, charge is less in the reactant side. And if I have to use H plus, definitely I will be adding H plus in the reactant side. Because as soon as I will add H plus, right, the charge will increase. And how much? The difference, 24 and 10 has a difference of 14. So if I add 14 H plus in the reactant side, 14 H plus in the reactant side, it gives me plus 14 charge. So now plus 14 plus 10 will become how much? Plus 24. And suppose that if you are doing the balancing in the basic medium, in that case, charge will be balanced using OH minus. Now try to understand this. Whenever you add OH minus at somewhere, the charge will decrease by 1 unit. Suppose that in the same case, instead of acidic medium, if I have to use basic medium, right? So I will be using OH minus for charge balancing. So in that case, I will be adding OH minus in the product side, because here I need to decrease from 24 to 10. So if I add here 14 OH minus, so it will decrease 14 charge from 24, it will become how much? 10. correct? So whether you want to increase the charge, use H plus. When you want to decrease the charge, use OH minus, depending upon what medium you have. But finally, now we have to look for the hydrogen and oxygen atom. Because when I am adding H plus for charge balancing, I am exceeding with hydrogen, right? I am adding extra hydrogen here. So now in the reactant side, calculate total number of hydrogen. This has no hydrogen, this has no hydrogen, this has 14 hydrogen. So in the reactant side, total I have 14 hydrogen atoms. In the product side, if you notice, there is no hydrogen. So for hydrogen here, I will be adding water molecule. One water molecule has 2 hydrogen. So for 14 hydrogen, I can add how much? 7H2O. 7H2O. So by adding 7H2O, I am balancing the hydrogen. Now if you notice, I have not tried to balance oxygen. I balanced the charge, I balanced the hydrogen atom. Oxygen atom will be automatically balanced here. And if oxygen is automatically balanced, that means you have done it correctly. Now count the oxygen atoms, all of you. In the product side, we have 7 oxygen here. In the reactant side, we have 7 oxygen. So reactant product have same number of oxygen, that means my balancing is right. So in the charge balancing part, you balance charge by H plus OH minus. Then if you balance hydrogen by H2O, then oxygen will be automatically balanced. And if you balance oxygen by H2O, then hydrogen will be automatically balanced. That means you have done correctly. So now I think you have understood all these steps of balancing in ion electron method, right? Separate, oxidation reduction, balance atoms by heat and trial, except oxygen, hydrogen, balance electrons that are getting transferred in oxidation reduction, add it again, and then finally do charge balancing, correct? So after understanding this balancing part, definitely it is our task to do some practice. So take your pen paper and now you try to do balancing according to me, right? The way I taught you, in the same way you try to do balancing. If you do 4 or 5 examples from this balancing part, then you will understand. And then you don't have even to revise this concept. It is a one-time study topic. One-time study means once you understand this, right, you don't have to revise it again and again. It will be in your mind always. So, can you all solve this question? For the redox reaction, the correct coefficient of the reactants for the balanced equation. Of course, they are asking for the coefficient, but you know very well that this is a question of balancing. And again, please pause the video, solve it first by your own, then match the answer, right? So, question is MnO4 minus reacting with oxalate to give you Mn2 plus and CO2, and we have to write down the coefficients of MnO4 minus, oxalate and H plus, of course. And one more thing, in the reaction you can notice that in the reactant side they have given H plus. So H plus comes from acid. So definitely this balancing will be done in acidic medium, correct? Now here we will be doing balancing a little bit faster because previously I was explaining it to you for the first time, so I was slow, but now we will do balancing, right, very fast. You know, if you do it faster, you can do balancing within 30 seconds even, correct? So the first step of balancing is what? Separation, right? Separate the oxidation half and reduction half. You know very well that for oxidation, reduction, separation, we need to assign oxidation number. We need to see which one is getting oxidized, reduced. So here in MnO4 minus, net charge is -1. So for O4, charge will be -8. So for Mn it will be +7. In C2O4 2 minus, net charge -2, O4 -8. So for 2 carbon, charge will be +6. H plus it is given. In CO2 for 2 oxygen -4. So carbon +4. And in H2O -2 +2. Now if you notice carefully here, Mn is changing from +7 to +2. So MnO4 minus is having reduction, and carbon per atom, in this case for 2 carbon it is +6. For 1 carbon it will be +3. So for 1 carbon it is going from +3 to +4. So carbon is having what? Oxidation here. So just separate them. The very first step, oxidation half and reduction half. In this case, oxidation half will be C2O4 2 minus converts to CO2, and reduction half will be MnO4 minus converts to Mn2 plus. And do not bother about what will happen to H plus and H2O, because I have not written that in the oxidation reduction half. In oxidation reduction half, write only those species which is getting oxidized or reduced. These things will come automatically during balancing of atom or during charge balancing part. So my first step is done here. I have separated oxidation reduction half. Now the second step, balance the atoms other than oxygen, hydrogen. So here if you notice, we have 2 carbon in the reactant, 1 carbon in the product. So multiply with 2 here to balance carbon. Forget about oxygen right now. 1 Mn, 1 Mn. So Mn is balanced, forget about oxygen right now, because oxygen, hydrogen we will balance during charge balancing. So now I am done with my second step. I have balanced all the atoms other than oxygen and hydrogen. So now go into the third step, that is balance electron. But again, before you balance electron, first you need to find out how many electrons are getting transferred. And that can be done by change in oxidation number, calculating change in oxidation number. And again I am telling you that here, when you calculate number of electron transferred, so change in oxidation number is calculated overall for total number of atoms, not for single atom, not for one atom. Like in this case for oxidation part, if you notice, for 2 carbon atom, the net charge is plus 6. In the product side for 1 carbon charge is plus 4, but now we have 2 carbon here also, so for 2 carbon it will be plus 8. So for overall 2 carbon, it is changing from plus 6 to plus 8, change of 2, and oxidation. So change of 2 means we are having loss of 2 electron. In the reduction part, if you notice, Mn has a charge of plus 7, here plus 2. It's going from plus 7 to plus 2, so we have a change of 5 here, and it is reduction, so gain of 5 electron. Now obviously the electrons are not equal. During oxidation we are having loss of 2 electron, and during reduction we are having gain of 5 electron. So how to balance that? Cross multiply. In the first equation we have 2 electron transfer, so multiply the second equation by 2. And in the second equation we have 5 electron transfer, so multiply the first equation by 5. Right? Now it will be 2 into 5, 10 electron, and 2 into 5, 10 electron. Now the last point, add it again. Why I am calling it the last step? Because I consider the charge balancing part separately. Because see, up to this we don't require medium. We require medium only in the charge balancing part. And these are the main points. Charge balancing part is very easy. So now if you add it, electron will be cancelled out, 10, 10, and it will be 5 C2O4 2 minus plus 2 MnO4 minus gives 5 into 2, 10 CO2 plus 2 Mn2 plus. Done? Now the final point, charge balancing. I already told you they have mentioned H plus here, which indicates it is a reaction of acidic medium. So in this case, charge balancing will be done with help of H plus ion. And you know that H plus will increase the charge. But first, calculate the total charge of reactant side and product side. In the reactant side, if you notice, 1 oxalate minus 2, so 5 oxalate will have minus 10 charge. 1 MnO4 has minus 1 charge, so 2 MnO4 will have minus 2 charge. So in the reactant side, the total charge is minus 12. In the product side, CO2 is a molecule, so net charge 0 for CO2. 1 Mn has plus 2, so 2 Mn has plus 4 charge. So in the product side, 0 plus 4, net charge will be plus 4. Of course, it is not same. Reactant side charge is minus 12, product side is plus 4. So we need to balance that charge with H plus. And definitely because H plus will increase the charge value, so we will add H plus here where charge is less. I need to bring this minus 12 to plus 4. So what I can do, I can add 16 H plus in the reactant side, because 16 H plus will give me plus 16 charge, and then plus 16 minus 12 will become plus 4. Right? So after adding 16 H plus, my charge has been balanced. Now because you are adding hydrogen, so balance hydrogen with H2O, and then oxygen will be self-balanced. In the reactant side, no hydrogen in these two. Here we have 16 hydrogen. So for 16 hydrogen, I can add 8 H2O in the product side. 8 into 2, 16 hydrogen. Now oxygen should be self-balanced. Right? If you notice, 5 into 4, 20 oxygen here, 2 into 4, 8 oxygen here. So 20 plus 8, 28. In the product side, 10 into 2, 20, and here 8. Product side also we have 28 oxygen. So balancing is done. Now, the coefficient of MnO4 minus, we are getting how much? 2. 2. So these two are possible. The coefficient of oxalate ion, we are getting 5. 5. Obviously, second will be the answer. And the coefficient of H plus, we are getting how much? So definitely the answer will be what? B, right? And this question we had in the NEET 2018 examination. So now I think we have done a little bit of practice in balancing. And you know what? We are providing you, I am providing you the DPPs, right, in the description and at PW app. So please download that and do self practice also along with the class practice, right? Classwork, homework, both are important. Now, can we do another problem, a similar kind of question? We have an equation, we have to answer the coefficients, right? So again, if you notice, in the equation they have written H plus. So this is a reaction of acidic medium. So we need to do balancing in acidic medium, and we have to follow the same steps. Can I do it a little bit faster? Right? A little bit faster. See, first step, separate, means oxidation, reduction, separation. Cr2 charge plus 12, sulfite, sulfur charge plus 4, plus 3, sulfate, sulfur charge is plus 6. So here oxidation is happening for sulfur and reduction is happening for chromium. So oxidation half will be your sulfite changing into sulfate, right? And reduction part will be your dichromate Cr2O7 2 minus converting into Cr3 plus. Separation done. Now balance atoms. Sulfur is already balanced. We are having 2 chromium here. So multiply with 2. Atoms are balanced other than oxygen, hydrogen. Now find number of electron transferred using change in oxidation number. So here we had plus 4 charge, here plus 6. So plus 4 say plus 6 is a change of 2. So 2 electrons loss. And here for 2 chromium charge was plus 12. And here for 1 chromium plus 3. So for 2 chromium plus 6. So plus 12 2 plus 6 change of 6. So here we have gain of 6 electron. Definitely electrons are not balanced here. So multiply this with 3. 2 into 3 will become 6. 6 will be cancelled. Next step, add them again. It will become how much? 3 sulfite plus chromate gives you 3 sulfate plus 2 Cr3 plus. Now, last step, charge balancing. So first get the charge of reactant product. 1 sulfite minus 2, 3 sulfite minus 6, 1 dichromate minus 2. Net charge of reactant is minus 8. 1 sulfate minus 2, 3 sulfate minus 6. 2 Cr3 plus will have plus 6 charge. So in the product side, net charge is 0. Definitely they are not equal, minus 8, 0. So here we have less charge. Here we have more charge. Again acidic medium, so balance charge by H plus. And you can add how much? 8 H plus in this case. 8 H plus will give you plus 8 charge. So plus 8 minus 8 net will be 0. It will be equals to the charge of product. Now for hydrogen, total we have 8 hydrogen in this because these two have no hydrogen. So for hydrogen I can use H2O. How many H2Os? 4 H2O. Oxygen should be self-balanced. In the product side I have 4 oxygen here and 4 into 3, 12 oxygen here. So 12 plus 4, 16, and here 7, 3 3s are 9. So balancing is done. Now they are asking the coefficients. Of course it should be A, B and C. A, B and C. So coefficient A means coefficient of dichromate. Coefficient of dichromate we are getting how much? 1. 1. So these two are possible. Then B is coefficient of sulfite. For sulfite we are getting 3. Here only we got the answer. Answer will be D. And C means coefficient of H plus. It should be what? 8. It is 8. So in this case the answer should be D, which is 138. So we did 2 questions, right, from balancing. Of course balancing is there, so you will be following same step every time. But this question came in NEET 2018 examination again. So now students, we have understood balancing, right? But as I told you that we have 2 methods, right? I will always suggest you follow the ion electron method only, always, right? But we have another method also. So once let us see that how that is performed, how that method is used. So we have another method called oxidation number method. In this case, see, both are similar kind, both are almost same. The main difference is in case of oxidation number method, you do not separate the equation, right? First point of difference is that. And secondly, here you do not balance the number of electron transfer. Instead of that, you directly balance the change in oxidation number. Those 2 points are different. And at the end, charge balancing will be done in both the cases. Like I have taken an example to explain that oxidation number method. If you notice carefully, here also we have to assign the oxidation numbers first. Here also we have to check which one is having oxidation, which one is having reduction. So in dichromate, we have 2 chromium whose charge is total plus 12. In sulfite, the charge of sulfur is plus 4. Here 1 chromium plus 3 charge. Sulfate, in this sulfur has a charge of plus 6. So you can clearly see that sulfur is getting oxidized in this and chromium is getting reduced in this. Now, first point is balance those atoms which are having oxidation and reduction. Balance those atoms first. So here we have 2 chromium. So here you should multiply by 2 to balance the chromium atom as chromium is getting reduced. Sulfur is already balanced. Here also you don't have to bother about oxygen and hydrogen, right? Now, after balancing the atoms by heat and trial method, you just calculate what is the change in oxidation number overall. Like here, for 2 chromium, oxidation number is plus 12, and here for 2 chromium, oxidation number is plus 6. So it is changing by, or I can write it like this, change in oxidation number here, it is 6. And for sulfur, if you notice, the oxidation number is changing by 2. So change in oxidation number 2 here, 6 here. Now balance this change. You have understood that in the same way you calculate number of electron and then you balance number of electron. So instead of balancing number of electron in this case, we just balance change in oxidation number. So 2 and 3 means multiply this with 3. So here also you will be having change in oxidation number of 6. So multiplying here with 3 means multiplying the whole equation by 3. Means here multiply with 3, here multiply with 3. Because when you multiply with 3, it will be 3 into plus 4, that means plus 12 total charge. And here it will be 3 into plus 6 plus 18. So now you can say that from plus 12 to plus 18, you are having change of 6. Right? And as soon as you balance the oxidation number, you are almost done. Because after that, you have to perform the same step of charge balancing here also. In this case, after balancing the oxidation number, the equation will become dichromate ion plus 3 sulfite ion gives you 2 Cr3 plus 3 sulfate. Right? Now, do the charge balancing. I hope that in the previous question also we had the same equation. So do the charge balancing now by your own, all of you, in acidic medium, of course, in acidic medium, of course, in acidic medium, of course. Right? And write the answer in the comment box, all of you. Just tell me in this question, all of you in comment box, that what will be the coefficients of H plus and H2O. I'm not asking for all of them because for dichromate and sulfite, we have already got coefficients are 1 and 3. So in the comment box, balance charge here and tell the coefficients of H plus and H2O, all of you. And I hope you have understood one thing, that both ion electron method and oxidation number method are quite similar. The main difference is here we do not separate the equation and we do not balance number of electron. Instead of that, we balance change in oxidation number. Right? So now I think in the redox reaction part, the main topics are done. Oxidation number, balancing and types of redox reaction. These three are the main points in this chapter. But we have to also deal with a little bit of redox titration. See, titration means, I hope you know that titration means finding concentration of an unknown solution. If a solution is there, solution A, and you don't know the molarity or normality or strength of that concentration. So when you calculate molarity, normality of an unknown solution, so that procedure is called what? Titration. Now here, when I say redox titration, because titrations have different parts, right? In your mole concept chapter, you talk about acid-base titration, right? So here we are talking about redox titration. Now what is the meaning of redox titration, students? You know that in redox reaction, compound A, compound B, they will react. Some of them will have oxidation, some of them will have reduction. So that means what? Some of them is a reducing agent and some of them is a oxidizing agent, right? Definitely, if redox is there, so there will be oxidizing and reducing agents. Now, in redox titration, what you do, either you calculate the concentration of reducing agent by the known concentration of oxidizing agent or vice versa, or you calculate the concentration of oxidizing agent with help of reducing agent, right? But before we proceed in detail, before we proceed with some questions of redox titration, let's first understand what are the terms we use in titration, and these terms we even use in the acid-base titration also. Like first term is analyte or titer. So analyte or titer is that solution whose concentration is unknown. The solution whose concentration is unknown. And basically you are going to calculate concentration of analyte using titration. So the solution with unknown concentration or whose concentration you are going to calculate is called as analyte or titer. Similarly, the other one is titrant, right? The solution with known concentration. The solution with known concentration, right? Now, we have two more points, like one is equivalence point and one is end point. Both looks quite similar, but they are not same. See, equivalence point and end point, both are the points or both are the time when your titration has been completed, right? The time when titration completes. So that point is called as equivalence point and end point. But they are measured differently. Equivalence point is measured or calculated by theoretical approach, right? By some calculation. And end point is always experimental. End point is experimental point, right? So when you do titration, you can see at the end of titration, after completion of titration, there can be change in color, especially for indicators and all. So when you evaluate, when you calculate the end of titration with help of experimental observation, so that point, that end of titration is called as end point. And when you calculate that by your pen and paper, especially using the law of equivalence and all, right? I will tell you later on what is law of equivalence. So when you calculate that by law of equivalence and all, so that is known as equivalence point. So equivalence point is theoretical calculation and end point is experimental observation. And finally, you know indicators, right? In titration we use indicator which tells you the end point actually. Indicator will give you what? End point. Indicator will not give you the equivalence point. Correct? Now, these are the terms which we use in the laboratory. But you people will be getting questions from the theory part, from the calculation part mostly. So here, for the calculation part, we need to understand few more terms like n factor. Again, if you don't know n factor, you can refer to the one shot of mole concept. In mole concept, I have explained n factor and even these terms completely. So you can see that video and from there you can learn n factor. In short, I am telling here, n factor, also known as valency factor. For acid it is number of ionizable H plus, for base it is number of ionizable OH minus, for salt it is charge of cation or anion. But here we are not dealing with acid base titration, we are dealing with redox titration. So in this case, n factor is number of moles of electron transferred per mole of substance. In this case, n factor is number of moles of electron transferred. And we have already seen in the balancing also, and previous to that also, I told you how to calculate number of electron transferred. So during oxidation reduction reaction, whatever number of electrons are getting transferred per mole of the compound, focus on that point, per mole of the substance. So that point is called as N factor. Let me give you an example. See, if you talk about Fe2 plus converting to Fe3 plus. So here number of electron transferred is 1. So I can say that 1 mole of Fe2 plus is losing 1 mole of electron. So in this case, N factor of Fe2 plus will be 1. And 1 Fe3 plus is getting created by 1 electron transfer. So for this also N factor will be 1. But suppose if I take this, oxalate converts to twice of CO2 by loss of 2 electron. In this case, if you notice, 1 mole of oxalate is losing 2 electron. So for oxalate, N factor will be 2. But for CO2, if you notice, 2 moles of CO2 is getting created by 2 moles of electron. So 1 mole of CO2 will be created by 1 mole electron, transfer of 1 mole electron. So for 1 mole, as 1 electron is getting transferred, its N factor is 1, right? So for 1 mole, like in this case 2 mole, we are having 2 electron transfer. So for 1 mole, whatever electron is transferred, that is called as N factor. That is called as N factor. Correct? I hope you have understood N factor, especially in case of oxidation reduction. Now, as soon as you understand N factor, you need to understand equivalent mass. In the redox reaction, sometimes you get direct question from this. And you know what? This can be calculated directly here. Equivalent mass of any oxidizing agent or reducing agent, equivalent mass of any oxidizing agent or reducing agent will be molar mass divided by N factor. So once you calculated N factor by number of electron transfer, from that only you can find what? Equivalent mass. Molar mass of the oxidizing agent, reducing agent divided by N factor of the oxidizing agent and reducing agent. Right? Now, after equivalent mass, we have another term, gram equivalent. I have already explained this, that it is a simple unit, just like mole and gram in the mole concept video of one shot, right? But again, I am telling you that gram equivalent is unit, and it has certain formulas, like gram equivalent can be calculated by given mass upon this equivalent mass. So you know mole, right? Mole is given mass by molar mass, right? So gram equivalent or equivalent is given mass by equivalent mass, this equivalent mass. Or it can be also calculated from mole into N factor. I prefer this. I always remember equivalent as mole into N factor, because from mole into N factor I can easily get given mass by equivalent mass. Correct? And then we have a concentration term here. Why I kept normality? Why I'm not talking about the rest of the concentration terms? Because during titration, the most used concentration term is normality and molarity. Although you know concentration terms from your mole concept chapter again, you know all the concentration terms, but here you have to focus more on the normality and molarity, right? So normality, it is calculated as equivalence of the solute divided by volume of solution in liter. This is the proper formula of normality. But you can also calculate normality from molarity using N factor. Molarity into N factor. So these 2-3 formulas you should always remember for the titration problem. Which formulas? Normality is equivalent by volume in liter. Normality equals to molarity into N factor. Gram equivalent is mole into N factor. Equivalent mass is molar mass by N factor. And then you should know that how to find N factor by number of electron transferred per mole of the substance. Again, I am repeating. So after understanding these terms, now finally I can talk about how to solve questions of titration. But believe me, questions of titration will be very easy for you if you understand this point, law of equivalence. What law of equivalence says? Students, whenever two compounds are reacting, even if it is not redox titration, some other reaction, so there also it is applicable. Whenever two compounds are reacting, compound A, compound B, right? So the amount in equivalent, whatever reacting, will be always equal, right? So in terms of equivalent, in terms of units of equivalence, suppose that this much amount of A is reacting, The equivalents of A is reacting with equivalents of B. So this will be equal. Law of equivalence says that in terms of equivalent unit, the reacted amounts will be always equal. Now the same approach we can apply in the redox titration. In the redox titration, suppose oxidizing agent is reacting with what? Reducing agent to give some product. So here, whatever amount of oxidizing agent will react should be equals to amount of reducing agent, but not in terms of gram or mole, in terms of gram equivalent only. In terms of mole and gram, they can be different, amount can be different. But in terms of equivalent, the amount will be equal. So, gram equivalent of oxidizing agent will be equals to gram equivalent of reducing agent. That's the logic. This is the main logic behind solving questions of redox titration. Always remember that. Right? So, let's take a question and you people take your pen paper and try to solve this question. Pause this video, read the question carefully and solve it first for me. For me. Whatever you do it for me. Right? No, you do it for your own, right? Own betterment. Studies are always best things to do in your life. Whether it is chemistry, physics, bio, anything. Study is the best part of our life. Okay, now solve this question. Number of moles of MnO4 minus permanganate required to oxidize 1 mole of ferrous oxalate. 1 mole of ferrous oxalate. Now here, if you notice, MnO4 is acting as oxidizing agent in acidic medium. So, for MnO4, please try to remember few points. See, the MnO4 minus ion in acidic medium, you can note it down, MnO4 minus in acidic medium, it converts into Mn2 plus. So, here it gains 5 electron per mole. In case of neutral or slightly alkaline medium, it converts into MnO2 plus 4. So, here it will gain how much? 3 electrons. And if it is strongly basic medium, then it converts into Mn plus 6 ion. So, here it will gain only 1 electron. So, this point you should remember for MnO4 minus, especially for this redox titration part, redox reaction part. Right? Acidic medium, 5 electron gain, neutral medium or slightly alkaline medium, 3 electron gain, strongly basic medium, 1 electron gain. Now, in this case, the medium is acidic. So, when MnO4 minus will work as oxidizing agent, this MnO4 minus will gain 5 electron to convert into how much? Mn2 plus. Now, before I proceed with the further ferrous oxalate part, you people tell me one thing. From this equation, can I easily tell the N factor of MnO4 minus? Of course I can, because 1 mole of MnO4 is gaining 5 electron. So for MnO4 minus in acidic medium, my N factor will be 5. Done. Now do the same for the ferrous oxalate, which is your reducing agent here. But in ferrous oxalate, we have an interesting point. Normally what you see that one of the species is getting reduced or one of the species is getting oxidized. But sometimes more than one species can go through oxidation or reduction. That will happen in ferrous oxalate. See, in ferrous oxalate, the formula is FeC2O4. Fe has charge of plus 2. C2O4 has charge of net minus 2, in which O4 minus 8 and C2 plus 6. Now, when this will be oxidized, so here we have two things which can be oxidized, Fe2 plus and oxalate. Fe2 plus will oxidize into Fe3 plus, while oxalate, just now you have seen, it will oxidize into twice of CO2. So here, for this oxidation process, for this reducing agent, if you try to calculate total electron transferred, so you have to see the both. You have to see both Fe and oxalate. In Fe2 plus, it is changing to Fe3 plus. So for Fe, we have loss of 1 electron. Now wait. For oxalate, it is going from plus 6 to plus 8 for 2 carbon. So for oxalate to CO2, we are having loss of 2 electron. So 1 electron loss for iron and 2 electron loss for oxalate. So what is the total number of electron lost here, right, in oxidation process? Total electron loss will be 3 here. 1 from iron, 2 from oxalate, right? So this is the equation of oxidation or reducing agent in this. Now again, from this equation, if I ask what is the N factor of this ferrous oxalate, you can easily say that, sir, 1 mole of this is transferring 3 electron, right? So its N factor will be how much? 3. Done. Now read the question. Now read the question, because I know in redox titration, the most important point is getting N factor. Once you have done with your N factor, you can solve the question. Now, the question is, number of moles of MnO4 minus we have to find, which is reacting with 1 mole of ferrous oxalate. Now, what I can do, I can blindly apply law of equivalence. I can blindly apply law of equivalence. I can say that here equivalence of MnO4 minus oxidizing agent should be equals to equivalence of FeC2O4. Now, according to the question, you can put your equivalence, gram equivalent, as normality into volume in liter. You can put it as molarity into N factor into volume in liter, or you can put it as mole into N factor. According to the question, you have to do it. Like in this question, they have given mole and they are asking mole. So what I will do, I will write equivalents as mole into N factor for both. So equivalents of MnO4 minus will be moles of MnO4 minus into N factor of MnO4 minus, right? And equivalents of FeC2O4 also I will write moles of FeC2O4 into N factor of FeC2O4. Now just substitute the values. What was given in the question? They are asking the moles of MnO4 minus. They have given 1 mole ferrous oxalate, right? So this we have to calculate. So let's put it X. But N factor of MnO4 minus, we know it is 5. And moles of FeC2O4 we have to take 1 mole, and N factor of this is 5. So here, if you calculate X, moles of MnO4 minus, it will be 3 by 5 or 0.6. 0.6, right? So definitely, in this case, your answer should be 0.6 mole. So I hope you have understood one thing, that in case of redox titration, you have to understand just the basic terms, right? N factor, gram equivalent, equivalent mass, and law of equivalent. And especially here, you need to understand the calculation of N factor. N factor calculation is very important here. So now students, if you summarize what we have discussed in this chapter, in this video, in this session, you will notice that we have covered, it's not even one shot. It's not one shot, it's the complete chapter. I have taken more time, right? More than expected time, but I have covered each and every point, right? So even if you are studying first time this chapter, you can complete it, right? By this one shot. So we covered each and every point, like calculation of oxidation number, like types of redox reaction, then balancing of redox reaction, then the terms, what is oxidation, reduction, oxidizing agent, reducing agent, and of course finally what is redox titration and what is important in redox titration. In redox titration, just follow on law of equivalence, N factor, gram equivalent, and the normality, molarity and their relation also. Correct? So now what is your homework? Homework is download the DPP, the practice sheets from the description, from the PW app, and be genuine from your heart, right? Genuinely solve all the questions that we are providing. Do not skip even one question from the sheet, from the practice sheet. And believe me, if you do that, you will master this chapter. You will master this redox reaction chapter. And in your NEET examination, whatever question you get from this chapter, you can do it by ease, right? So keep rocking. Thank you so much. Over and out. Bye-bye.